Great. So we have a lot of informative presentations for you today, and if you're attending in person, we have some opportunities to interact with you as well. As for what to expect on our agenda, we have 3 sessions with 15-minute breaks in between sessions. So we'll start with an introduction to our program, who we are, what our teams do, and a little bit of history. And we have some special presentations to introduce one of the methods that bind our 2 teams together, the ROV. So you want to stick around so you can come up close and see what that technology looks like at the end of session 1. In session 2, we'll go through some of the research, monitoring, and analysis we'll do in the marine reserves and the coast in general. And in session 3, we'll host a panel with some of the Marine Reserve's wonderful community partners who are joining us to talk about art, science, and stewardship. That'll be followed by a talk by Dr. Sarah Klain of the University of Oregon, who was our previous Human Dimensions project lead. And then we'll close out with a look at the seafloor mapping that we've done at Rogue Reef. Well, we have a lot of topics and updates for you today. We're trying to stay in a specific time frame, so we only have time for a few questions within each session. However, we invite you to join us for a networking reception at the end of the day from 5 to 6 p.m., where you can enjoy some hors d'oeuvres and visit tables from our community partners, and absolutely take that time to ask anyone from the Nearshore Ecology Program questions or discuss the research you heard about here. Not everyone in the program is presenting today, but everyone is in person. So Nearshore Ecology Program, would you please take a stand from wherever you're sitting? Great. Thank you. So please remember these faces and feel free to ask them questions during breaks or after the sessions are complete at the end of the day. We really look forward to engaging with you during that hour. And also an added note, if you haven't signed in yet in the double doors outside, please take an opportunity at the next break to go and sign up. And we have some name tags and tasty treats for you as well during the breaks. We also have some hopes for what you take away from your time with us today. By the end of the day, our goal is for you to leave with a better understanding of what the Nearshore Ecology Program is and who we are. Spoiler, it's the Marine Reserves and Marine Habitat teams, as well as the breadth of work that we do and learn something new. We hope that you also get a chance to tell us what you've learned. At the end of the day, we have a survey with a link that we'll send out to you and have a QR code as well. And before we dive into the content of the day, we have a few ground rules and housekeeping items to cover. We ask that you be as present as you can be. We totally understand that not everyone can stay for the entire day or even for a whole session, so please just quietly watch your step on the way down. The stairway is lighted, and make your way out of the room when you need to. And that if you are going to use your phone, please step outside and please silence your phones at this time. And if you need to get up and stretch, totally acceptable. Please take care of yourselves. We also ask that you stay curious and open to learning, and questions are absolutely encouraged. We've grouped certain presentations together, like our program and team introductions, so that all presenters can answer questions at the end of similar talks. We'll let you know when we have the time scheduled for questions throughout our sessions, and are looking forward to your questions at the end of the day. If you're online, please feel free to submit questions in the Q&A, but please know that we'll likely not get to them live today. We will be recording all of them to follow up with you later. If you're asking a question in the room, please raise your hand and wait for a mic to get to you so that the folks online will be able to hear the questions too. And please help us stay on time. Like I said, we're working in a time frame with a lot of presentations. We'll give a 2-minute warning when we near the end of a break, and that will look like me personally coming outside and ringing a physical bell from my grandmother, so it will let you know when you can come back in the room. And we love feedback. So please, take our survey for a chance to win a Marine Reserves prize pack. At the end of the day, after the meeting, you'll be sent all the QR codes and links from everything that you see in the presentations, but especially that link to the survey. And with that, we'd like to start into the meat of what the Nearshore Ecology Program is and how it began. So last year, Oregon Department of Fish and Wildlife's Marine Resource Program reorganized our marine reserves and marine habitat teams into one program, the Nearshore Ecology Program. The new organization brings efforts focused on marine conservation and habitat characterization under one roof. The hope is that this unification will strengthen collaborations, techniques, and teamwork around two groups historically focused on marine conservation science. The Nearshore Ecology Program is composed of the Marine Habitat and Marine Reserves teams. Combining these teams facilitates the sharing of technical expertise, widens collaborative abilities, and improves teamwork critical to the retention of institutional knowledge. The Marine Reserves team is more place-based and conducts ecological monitoring at the reserves and control sites, social science research to understand how people use, relate to, and value marine reserves, and communication and outreach. The Marine Habitat team studies topics coastwide in and beyond the marine reserves. They focus on understanding nearshore habitats more broadly and research seafloor communities. They also contribute to management decisions and policy development that support sustainability and conservation on the coastal, state, and federal level. We're excited to present this collaboration formally to you all and want to assure you something that hopefully those who have been working with us over the past year can see. The core work of these two teams is not shifting away from their original core work, as these two teams have distinct as well as overlapping goals. This graphic represents the methods that our two teams use to achieve their goals. It's not inclusive of all of our methods and research collaborations, but it does represent our core work. So going clockwise around this circle, in the top right quadrant, you'll find the methods that our Marine Reserve team use for ecological research. The bottom right quadrant demonstrates some of the ways the Marine Reserve participates in communications and engagement. The bottom left quadrant showcases some of our Marine Reserve's Human Dimension Toolkit, and the top left quadrant shows the methods marine habitat currently focuses on. You'll see the graphic throughout the day to identify which topic each team is presenting on, and it's our hope that you'll get a better idea of the breadth of work that Nearshore Ecology Program as a whole is engaged in. So the program goals are composed of the team's individual goals and focuses on where we overlap. OPAC 2008 was the foundational mandate that set up the Marine Reserve's overarching goals. That's to conserve marine habitats and biodiversity in these 5 areas on the map shown here. That's also to use marine reserves as points of scientific research to inform nearshore management and to research these scientific and ecological goals while avoiding significant adverse impacts to coastal communities and creating a sense of place. Our marine habitat team doesn't have any legislative mandates, but has priorities to synthesize data on Oregon's nearshore and continental shelf, promote wider access to and understanding of seafloor habitat data, provide policy and management guidance on the coastal, state, and federal level, like I mentioned before, and to study species distributions, implement nearshore strategies, assist in marine spatial planning, and also provide fishery independent survey data. So hopefully you can start to see where the overlapping goals are taking shape in these two teams. And we're just over a year old as a program now and still growing into what we ultimately will look like. What we do know and can communicate to you today is that we have a larger knowledge base together and that our teams have very complementary skill sets. We also have several overlapping goals and great capacity to grow together over time. Some of these programmatic goals are fostering a more holistic view of Oregon's nearshore ecology and conservation. We also provide the state of Oregon with fishery independent surveys and monitoring, and can use this data to inform many different kinds of research questions, as well as meet evolving data needs and knowledge gaps. We aim to cross-fertilize our ideas, techniques, skill sets, and publication efforts, and also have more capacity for collaborations. By continuing to learn and grow together, we'll improve access to institutional knowledge within the program. And since we've gone through what we hope to accomplish, I'd like to introduce who we are. I've introduced myself already, and highlighted in teal is our Marine Reserves team. Dr. Moritz Schmitz, Dr. Dylan Gomes, Stephanie Fields, and Ryan Fields are our ecological team. We'll soon be able to introduce our new Human Dimensions project lead. I know some of you have already been asking about it. And once we're able to reveal the identity, we absolutely will. That hiring process is still underway, but we're very close. Right now, I am proud to introduce the 3 positions that House Bill 4132 is able to create on our Marine Reserves team. That would be Dr. Dylan Gomes, our quantitative marine ecologist, Ashley Lowe McKenzie, our new marine economist, and Katie Dar, our new communications and engagement specialist. As a note, myself, Dylan, Ashley, and Katie have been on the job for just about a year or less, so we're not just growing as a program, but as a team as well. And now highlighted in green, we have the Marine Habitat team. This is led by Scott Marion, and assistant project leads Arlene Merrims and Bill Miller, and marine biologist and video reviewer Steve Capillas. I'd also like to acknowledge our 2025 staff not listed here, including Amanda Gannon and Sam Cheplick, our previous Sea Grant Fellows, Dr. Sarah Klain, our previous Human Dimensions project leader, who's here with us today and will be presenting, and Sarah Sampson, our seasonal ecological research assistant. And special shout out to Tommy Swearingen, who was a fundamental part of the Marine Reserve's human dimension research in the past, and in the present, or rather the past several weeks, has been a very involved part of our candidate search and interview process for our next Human Dimensions project lead. And since we've talked about what we'd like to accomplish and who's accomplishing it, let's move on to how we accomplish it with everyone's favorite topic, budget. We got some questions about budget during the registration for this event, so we want to make sure we touched on it. To clarify, there's no additional allotment of funds for the Nearshore Ecology Program. The budget's comprised of Marine Reserve and Marine Habitat budgets, which come from different places. The Marine Reserves team is funded by part of the state budget called the General Fund, and the Marine Habitat team is largely funded by the Commercial Fish Fund and external grants. The Commercial Fish Fund comes from fishing license fees and is the way many projects in ODFW are funded. Another question asked about how the state funding generally affects the marine reserves and what the funding outlook was for this year. So generally, when there's less state budget for Oregon, there's less money for our allocation of the general fund, and the general fund works on a 2-year cycle. Hot off the presses of this legislative session that ended last Sunday is this biennium for the Marine Reserves team is balanced at the expected level that includes what House Bill 4132 allocated to us. We don't expect to see any change or reduction beyond the already accrued vacancy savings in Marine Reserves. And now that we have an understanding of the Nearshore Ecology Program, we'll zoom in on specific teams, starting with the Marine Reserves. Here are the Marine Reserve core tools on this graphic that's probably already getting a little bit more familiar to you. We saw this map of the Oregon coast before, but again, the red squares are Marine Reserves and the blue squares surrounding them are MBAs. If you're having a hard time seeing the red and blue squares, please take a look at the 5 stickers up and down the coast and see the arrows that point into them. The Marine Reserves take up 3% of state waters, and the MPAs take an additional 6% of state waters surrounding the little marine reserves. So what is a marine reserve and how is it different from a marine protected area? Marine reserve are our strictest no-take areas and don't allow ocean development or fishing, whereas marine protected areas don't allow ocean development, but do allow some amount of fishing depending on which MPA we're talking about. And we've already talked now about Marine Reserve goals of conservation, research, and community. To reach these goals, our team needs resources. We've seen, and we have 7 full-time staff who we've seen the faces of and mentioned before. That includes 4 ecological team members, 1 human dimension staff, 1 economist, and 1 communications and outreach specialist, plus various fellows, interns, and temps at different points in time. We also rely on our partners at the Oregon State Police to provide enforcement and ensure compliance with regulations at our Marine Reserve sites. Our budget fluctuates from cycle to cycle, but this biennium is projected to provide $3.4 million in state general funds. This is the current configuration of our team, but the faces in these bubbles look different throughout the years, and we wouldn't be here without the efforts of our previous team members. I know many of them are here with us in person or online, so I'd like to take a moment to thank them for paving the way to getting us to where we are today. And just with our previous team members, we truly can't do this work without our current collaborators. You'll see some logos now which represent some of the samples of the groups and partners we work with. As a fun exercise to get us moving a little, because you all have been listening to me talk for a while now, please feel free to stand up or raise your hand as I call out a group that you're involved with or work with us personally. So any of the state agency partners from state parks, Department of State Lands, OSP, or DLCD, feel free to keep your hand raised. If you're a part of any of our community partners, please feel free to raise your hand. And if you're part of any of the academic institutions that we work with, or any of the nonprofit agencies or multi-agency groups we collaborate with, including local fishermen, vessels, charter offices, volunteers, and anyone that works with us that I haven't called out. If everyone could raise their hand if I just called any of our groups. Amazing. So that's a lot of people and partnerships to be proud of. You guys put down your hands really fast, but if they were still up, I would ask you to help me in celebrating you and helping us to conserve, protect, and research Oregon's near shore. Thank you so much for your effort and time that you spend with us and doing the work that you do. So thank you. And now that we have an idea of where we are now, let's take a journey back in time. You might be wondering how marine reserves began or what those mandates are that I mentioned earlier. We've had several marine reserves related acts passed by the legislature in the years that followed our original 2008 mandates, and we'll talk about a few of them today. Here's some of that information summed up in a handy timeline. After the community-based process to select the 5 sites, the legislature passed a bill in 2012 establishing them in full. That bill, State Bill 1510, also called for an assessment of the Marine Reserves program in a decade. Ahead of this assessment, the Marine Reserves team prepared a very long and detailed report to help inform the reviewers of the program's activities to date. The assessment, which was conducted by a team of external university researchers, completed this review in late 2022. In 2024, the recommendations from this assessment report were condensed and enshrined into a new bill, House Bill 4132. This bill provided more funding and laid out new requirements for creating an adaptive management plan for our program. Amanda Gannon, our last Sea Grant Fellow, advanced our understanding of adaptive management and how it applies to marine reserves. We're still at the early stages of this process, which has involved a lot of internal planning, but I want to share that process is happening on that front. So stay tuned to learn more about where we're headed. And before we continue, please join me in reflecting on this journey Marine Reserves has been on. We've thanked our current collaborators and previous staff, but there's a vital bit of the picture we're missing. That initial executive order and House Bill 3013 formalized the community teams to kick off the planning process and site selection work for the Marine Reserves. If you are part of any of the initial community teams or participated in any of the meetings that helped create the Marine Reserves as we know them today, please raise your hand, and if you're online, put a react emoji. Excellent. We would love to extend our gratitude to you in recognition for all the effort you put into the Marine Reserves. And now, please join me in a round of applause for these super sea stars. Thank you for being here today. And with that, it's my pleasure to present my esteemed colleague, Dr. Moritz Schmidt, our Marine Reserves Ecological Project Lead.
Thank you very much, Maria. Hello, everybody. Today, I'm going to take us through a worldwide explanation of what it is that the ecological team does in the marine reserves. So, as Maria pointed out, we are in the upper right-hand quadrant of the new Nearshore Ecology Program. And I want to take a little bit to talk about some focus area of the work that we do. These are tied really closely to the mandates that we have from the Oregon legislature. And so those really are situated around habitats and biodiversity and understanding them and conserving them. And we use multiple different survey tools and scientific surveys to understand that biodiversity and habitats. Now, we couldn't do all the work we do without our collaborations, because these collaborations really enable us to enhance our capacity, especially for surveys and looking at different components of biodiversity. And you're going to hear more about that in my following slides. Then a last overarching area that we have is our ecological analyses, because we have all these data streams. Of course, we do have to analyze them, and we also then have different venues of publishing them, for instance, through newsletters to our volunteers and captains, and also, ranging all the way through peer-reviewed publications. Our core ecological research tools are hook and line fishing for adult fish. We do also do scuba surveys together with the Oregon Coast Aquarium and OSU, looking or focusing on invertebrates, kelp, and adult fish. Then in-house, we do collaborate with the marine habitat team very closely on the use of the remotely operated vehicle, or short ROV. And Scott will talk a lot more about that in his presentation. And then last but not least, oceanography, and having oceanographic moorings and sensors in the reserves and outside reserves is also very important for us. That means that, broadly speaking, we really range from looking at different invertebrates through, for instance, intertidal surveys as well as subtidal surveys. We look at adult fishes and juvenile fishes. We look at macroalgae, so think kelp. We look at habitat and also oceanography. I want to take a second to also talk about how our team's presentations today kind of tie that picture together. And reflect our goals. So Ryan will be talking about fish catch in different reserves and for different species, and how that is linked to the expectations that we have for the different reserves. Stephanie will be talking about how we use a large body of volunteers to get our work done, and also how we, in the past and currently, use expert knowledge from captains in our work. And last but not least, Dylan will be talking about cross-reserves and cross-tool approaches to understanding broader biodiversity patterns. An important concept to keep in mind is, again, that for MPAs and reserves in general, design and placement really matter. And of course, it does so too for our marine reserves here. So for instance, the size, bathymetry, the type of habitats that a reserve encompasses, think rocky reefs here on the Oregon coast, but also the biology and ecology of species really drive a lot of the potential conservation outcomes from a protected area. And so does, of course, prior use of reserves before closure. So was there low fishing pressure or, for instance, high fishing pressure in a reserve? And on the left-hand side here, you can see our Otter Rock Marine Reserve, which is very close to here, which encompasses just over 1 square mile. Another important thing to know about our work is that we do work in reserves as well as comparison areas. These comparison areas are chosen to match these attributes of our reserves as closely as possible, because what we can then do is we can track change over time in reserves compared to these other areas that do not experience the closure and extra regulations that the reserves experience. So, as I mentioned, hook and line and long line are an important part of our work. And here you can just see some pictures of us going out with volunteers out of Garibaldi, for instance. All these volunteers do the fishing for us. We also have additional volunteers who help us write down data and staff IDs, measures, and sexes individuals, and then releases them safely again. You'll hear more about that later. And then a shout out to our community in Port Orford that has an active longline fishery going, where we also work with captains when our capacity allows to do longline surveys and get at that, get at those data and mimicking those surveys. Sorry, that fishing pressure. Then yes, our scuba surveys, and we have several of our collaborators on that in the audience. Thanks for coming. We do have, each year we go out into different marine reserves to look at invertebrates and adult fish through visual scientific dive surveys. And each year we have in early April a dive training, which is coming up very fast for this year. Here you can see folks training in the tanks at the aquarium. And then the team goes out every year on several dive days to do actual visual transect in the reserves and comparison areas. Please feel free to ask questions about that later. Then another big part of our work, as I pointed out, are these ROV surveys. I just have some nice pictures here that we put together over time. Again, Scott will talk about that more in his section, but the ROV tool enables us to get really large quantities of underwater video data that is really helpful in understanding what's going on. Then I want to touch on oceanography and our need to survey that oceanography along the coast. And that is, of course, through the need that we have as a program helping us to disentangle reserves effects and oceanographic effects from the signals that we see. But probably even larger than that, that data is in general still very scarce in state waters and especially moorings over time that give us an idea what's going on over a whole season. And you can see why that is important right here. For the 2025 data, so last year, we have plotted here in green the Cape Falcon dissolved oxygen, with the red dashed line here being the border where underneath here we have hypoxic waters, so waters with low oxygen that have potential negative effects on different species and in different ways. Whereas at Redfish Rocks, the red line, we see that we had a lot of, over summer, a lot less days where waters actually were hypoxic. So you can see that it's important to take this into account in order to interpret our data. And now I want to touch on collaborations. Awesome. We have several long-standing collaborations and some ones that we started more recently, and I hope to give you a good overview here. Arlene is not indicating anything yet, so I think I have some good time here. This is awesome. Yeah, we do work since over 15 years. We work with OSU and the aquarium together on monitoring juvenile fish in reserves and outside of reserves. And we do that through what we often endearingly refer to as SMURFs, which stands for Standard Monitoring Units for the Recruitment of Fishes. And we have some collaborators online as well as in person here. So feel free to ask the hard questions, Cameron, later in the break. But basically, we have these contraptions out in the waters, and they mimic kelp. So by sampling the fish that we can find in that artificial kelp, we can monitor the amount of fish that recruit to the nearshore. And I'm going to leave it at that. Another long-standing collaboration we have is on the oceanography at Cape Perpetua, also with OSU researchers. And you can see them here getting ready to deploy sophisticated oceanographic mooring that also surveys for things such as salinity and chlorophyll A. So again, getting us an understanding of the environment that our animals are living in. Another long-standing collaboration also is our rocky intertidal monitoring. So looking at organisms, for instance, in tide pools at Cascade Head and Otter Rock. And we do that with researchers at Cal Poly and OSU. More recently, we started some very interesting collaborations also. So for instance, we do look at shark migration on, along the Oregon coast and how these sharks may use or not use marine reserves, and to get at the whys of that, of course. And that uses acoustic tags, genetic analyses of the tissue, as well as eDNA analysis. And we do that with researchers at OSU as well. And I believe some of them also in the room or online. Another newer collaboration and interesting one is on pesticides in marine reserves. And now I have to actually hurry up, so I'll do that. But very interesting here is that pesticides, on land are very well researched, but in the ocean, I think, explainably, very little understood. Elise told me recently that there's only 2 or 3 papers worldwide that look at pesticides in non-estuarine ocean waters. So we are looking here to sample pesticides in marine reserves. And then last but not least, we do look at the resilience of kelp forests in Oregon nearshore waters with our OSU researchers as well. And we do that through modeling the effects of urchin grazing and heat waves on the survivability of kelp forests. Sorry, we can't go into more detail here, but feel free to ask questions later. And with that, I thank you. And if you want to connect, please reach out.
Hello, everyone. My name is Ashley Lowe McKenzie, and I am the Marine Resource Economist. It's a new position that was developed through HB 4132, and it's part of the human dimension of the Marine Reserve, which is, if we go back to this diagram, it's over here in the bottom left corner that gives us the different methods that we use to approach human dimension questions, which involve what are the economic impacts to fishers and local communities, what are the social impacts, and the knowledge and attitudes of support for marine reserves. And the challenge behind this is that what impacts can we measure accurately, and who decides and how do we get those into our decision-making framework? So topics that we study involve both the economics and demographics, as well as the knowledge and perception of marine reserves to all inform the resilience that we're incorporating into our system in our efforts of conservation. And we use different types of data to do that, including focus groups, interviews, observations, and surveys and secondary data to be able to answer some of those questions. So far, this work here that I'm presenting on is work that happened before I entered this position, but the economic impacts right now, no discernible adverse impacts on landings or permits purchased or aggregated commercial fisheries. And there's been low self-reported efforts of shifts. But there's been an increase in support and favorability and knowledge and understanding of these marine reserve sites, with less than 10% of fishermen surveyed opposing the reserves. This is coming from an aquatic conservation publication in 2022. But the recent projects of 2025 have looked into projects of ocean values of Spanish-speaking Oregonians. Inside the parentheses are some of our collaborators on these works. The attitudes and opinions and willingness to pay for reserves and blue carbon habitat, augmented reality in Otter Rock, a redfish rocks economic contribution study, and human well-being indicators linked to the marine reserves, which you'll be hearing about more with Sarah's talk later in the day. So what's next? Well, the new mandate of HB 4132 gave us some guidance to incorporate recommendations from the assessment report, which includes taking an adaptive management approach, incorporating SMART goals, and using that to better incorporate what we're learning in our decision making. And it also created my position, like I mentioned, and the goals for my position going forward. I'm hoping to get this total economic view of the marine protected areas, focusing in on Oregon marine reserves. When we think about this as an environmental economist, we will break these down into various different types of values, like use values that can incorporate the direct use of the resource, both outputs, services that are directly non-consumptive use, such as recreation, tourism, and research, or the indirect use of those resources. So the benefits associated with a functioning ecosystem through the conservation of the marine spaces. You can think of that as an example of trying to value ecosystem resilience, as well as option values, protecting areas for future use, both the direct and indirect uses as mentioned before. Use values is just one. We would be remiss to not mention the non-use values we get from our conservation efforts, such as bequest values, values placed on conserving for future generation. An example of this is a public trust. We think of this often on land for our national parks, but here we're talking about it in marine spaces, as well as existence value, the value we get from knowing and the knowledge of a continued existence of a species or a resource. Examples of that, we see that there is value behind the Endangered Species Act. And so with that, I'm rethinking the value and developing collaborations with various different universities and federal agencies, as well as independent contractors. I'd like to note that the current exploring indirect values of marine resources with an economist, Dr. Stephen Dundas at Oregon State. So look forward to seeing that work in the future. And the human dimension priorities will be developing their own collaborations once they come in and fill in that position, which we look forward to. And now with that, I will pass it to Katie Dar.
Thanks, Ashley. Excited to be with you all today. My name is Katie Dar. I'm the Communications and Engagement Specialist with the Marine Reserves team in the Nearshore Ecology Program. As Maria mentioned earlier, this position returned to Marine Reserves with the passage of House Bill 4132, and tomorrow marks 1 year in this role for me, which is very exciting. The core of my work exists in the bottom right corner of our diagram here, focused on knowledge sharing, partnership building, community engagement, and outreach. And while I lead these efforts, I want to thank the whole team, as well as our community partners, for all of the hard work that they do to support communications, outreach, and engagement in addition to their own research and responsibilities. So in addition to partnership building, which has been a large focus of my work over this past year as I get to know folks on the coast again, the Marine Reserve's work has included, maybe if the slide wants to advance for me. Didn't mean to add this level of suspense for everyone. Wow. We've tried all 3 options to advance the slide. Let's see. Thanks, Maria. Magic touch, the program leader. So I've reintroduced our quarterly newsletter for Marine Reserves. That was after a nearly 2-year hiatus, which is really exciting for us to bring that back and provide folks more regular updates about the work that's going on, what you can expect to see, and opportunities to get involved. Our eco team has been hard at work annually putting out their Fish on Hook and Line newsletter for volunteers and other interested parties who want to see what we're learning from those hook and line surveys. We have, really glad I put those animations in. Okay, we have put out press releases this year highlighting the work of some of our human dimension studies, both internally and collaborations with partners. We have a lovely website that has been neglected for a little while, so slowly but surely making our way through updates on that. One piece I'm really proud of is the events calendar that we now have to highlight where you can expect to see us talking about our work or where our partners might be highlighting marine reserves and places like this and beyond for you to learn more and get involved. Social media, you can follow the ODFW Marine Instagram account, which highlights work of the Nearshore Ecology Program, as well as broader than that with all of ODFW's marine program. And Marine Reserves has a YouTube account as well that we have some great videos on. We've tabled at a variety of community events with our trivia wheel and our hook and line survey demo activity at the Portland Aquarium Select Family Math and Science Night. Some of these other places you can see on the slide. We love to invite people into our world and our work, but we are making a concerted effort to really meet people where they are and explore different avenues for outreach and engagement and opportunities to engage with folks who might not normally engage with ODFW and with Marine Reserves topics. So you can see we went to Portland Pride and Newport Pride last year and just sort of trying to get beyond the sort of fishing and environmentally focused spaces that we might normally be tabling at. Our team members presented about our work and opportunities to get involved to a variety of audiences. So we had Fish for Science RFP meetings to share with captains about our contracting opportunities. We did talks with our OSU collaborators about the Smurf surveys or the juvenile fish studies. And several members of the Nearshore Ecology Program team presented at the State of the Coast Conference and more. We hosted and participated in a variety of events, including the Seven Capes Bird Alliance's Otter Crest Loop Walk back in July, and that was a really wonderful way for us to work with a partner and share with the public how marine reserves fit into a broader component of a mosaic of protected areas on the coast, in addition to the marine reserve, the marine protected area, how we fit into these other existing designations. We had our Otter Rock augmented reality launch experience, which I'll send out that QR code and hope that you check that experience out on your own time. Wow, we really love not advancing today. Okay, got it. Thanks for your patience. And I do want to shout out our 5 community teams, North Coast Land Conservancy, Cascade Head Biosphere Collaborative, Friends of Otter Rock Marine Reserve, the Redfish Rocks Community Team, and the Cape Perpetua Collaborative, as well as the Oregon Marine Reserves Partnership for the incredible work that they've done in this last year and beyond to expand our own outreach capacity. You'll hear more from some of them later in the panel about the creative ways that they foster stewardship of Oregon's coast. And I'm grateful for all of the partners that we have who do lots of things to spread the word about marine reserves and ways to get involved. And a great way for community members to engage further with marine reserves is by getting involved with our community teams and partners through their events and volunteer opportunities. Okay, and I'm on my last slide here. Community engagement was central to the inception of marine reserves and remains a guiding pillar of our work. And I'm looking forward to expanding our engagement efforts in this next year and beyond, particularly as we continue to build tribal relationships and work to better engage fishing communities. I think our adaptive management planning and site management plan updates offer rich grounds for engagement in the near future. And with that, I'll pass it over to Scott Marion to talk about marine habitat.
Okay, thanks all. We are up here in the marine habitat quadrant of things. And so I'm coming to you today with a bit of perspective that many of you are probably much more familiar with the Marine Reserve Program through their excellent work and outreach and history of engagement in the community, and not so familiar with the Marine Habitat Project, which now we're all one big happy family. You're going to be hearing a lot from me today, and that's because we think we have more work to do to get you familiar with what we are doing. And so we're going to start off with just introducing the team and talking about our goals and our activities, and then giving you a bit of a historical lens of how our group got to where we are, the kinds of projects we've been engaged in. We are myself, project leader Bill Miller, Arlene Merrims, and Steve Capillas. And we've categorized our current goals in sort of three broad categories. The first is nearshore species distributions and ecology. Second is seafloor habitat assessments. And the third is providing guidance on resource management and policy. We'll march through these in some detail. So the first of those is nearshore species distributions and ecology. We're really focused on improving our understanding of the relationship between nearshore species and seafloor habitats. We are identifying gaps in the State Wildlife Action Plan and conducting surveys to fill those gaps. And we have a goal of implementing analyses to quantify and model species habitat relationships to address management concerns. You can see an example on the right here of where we have GIS maps showing substrates overlaid with ROV transects and the locations of where we've seen fish. So these are the ways we sort of work with the data to relate organisms and their environment. The second broad category of goals is working on seafloor habitat assessments. So we gather and interpret data on seafloor habitats for a number of purposes. We identify data gaps and fill them through new surveys. On the right is an example of a survey that we just conducted down at Rogue Reef. I'll be talking about that a little later this afternoon. And finally, promoting access to and understanding of seafloor habitat data itself. We're sort of curators of that data within the Marine Program. And that third category of goals, providing guidance on resource management and policy. We have a goal of providing marine habitat expertise, data, and analysis that informs fisheries managers and state and federal policies and permits that might be related to, that might have marine habitat impacts. An example on the right there is work we've been doing on fiber optic cables and their placement in relationship with nearshore habitats. So those are our three categories of goals. Let's talk a little bit about our activities and kind of how we actually spend our time. We have a very diverse portfolio of activities in a very broad scope. These are three sort of slightly different categories, but in the research, monitoring, and mapping, a lot of things fall under the general category of surveys on abundance and habitat associations. So we're largely focused on nearshore rocky reefs. The ROV is one of our primary sampling tools that's been played into, the Marine Reserve assessments have been a core part of our portfolio. Historically, the group did fishing and scuba surveys. We haven't done that as much recently. We've done kelp biomass assessments and fishery independent ROV surveys and worked that data forward for availability into stock assessments through some modeling work. Other categories in research and monitoring are the habitat mapping itself, so focusing on aerial surveys of the bull kelp canopy, the seafloor mapping, and a rocky shores inventory that was work that was done quite a long time ago now. Another category is hypoxia research that was active it was one of the first programs that was really focusing on hypoxia research. And the odd one out here is oil spill response. We're trained up and ready to respond to assessing natural resource damage from any unfortunate oil spills. Moving over to the category of resource management and policy analysis and guidance, there is a whole just litany and a seemingly unending series of issues that come in front of us. And so we engage with state agency partners and federal partners and work through the Pacific Fishery Management Council to address, analyze, comment on, provide comment letters on all sorts of issues that come up. Some of these are coastal zone federal consistency, the Rocky Shore site designation process, marine renewable energy, dredge material disposal, et cetera. Those are many items in that category. Another area of focus is analysis of actions that may affect Pacific Fishery Management Council essential fish habitat for salmon and for groundfish. And finally, providing support for the Marine Resources Program on GIS data sort of consolidation and curation. And finally, category of activities falls under marine spatial planning, working with large data sets. So the Territorial Sea Plan and its revisions, we've been involved heavily in those activities. The Nearshore Ecological Data Atlas is an example of a large-scale data synthesis exercise a number of years ago. We'll touch on that in a little bit. And compilation of data that has gone into planning for offshore wind energy. Okay, so that's kind of our current snapshots. That's what we do in a nutshell. I want to take you back and look at activities we've been involved in and where that came from. A big driving impetus was in the late 80s, the outer continental shelf of oil and gas leasing was proposed, and that was sort of a wake-up call for the need for the state to be prepared with understanding about the nearshore environment and looking at what potential impacts might be. The Marine Habitat Program, we were actually a program at that time, was created in 1989. Yes, that is 37 years ago. We've had a representative, Arlene Merrims, who's been with that program every one of those 37 years. And thanks to her for a lot of this historical information that I'm presenting to you today. That sort of driving focus was a theme that kind of drove a lot of the responses of understanding the state had to be ready for what various nearshore impacts might be. So the creation of OPAC in 1991, the original Territorial Sea Plan, and its eventual revisions flowed after that point. In those early days, the Marine Habitat Program was engaged in some of the pioneering uses of GIS to take logbook fishery data and turn that into spatial analysis that would be available to see where habitats might be sensitive to offshore oil and gas industry. So here's an example that Arlene was involved in of painstakingly compiling all these data out of logbooks and using the early days of GIS to portray that information spatially. One of the first studies that filled the role of actually creating new data and creating new understanding about the nearshore communities was what we call the CORE study, the Cooperative Reef Ecosystem Study. And that included longline, hook and line sampling, scuba diving, seabird analysis, marine mammal diet studies, habitat mapping, oceanographic sampling, even submersible work offshore, and focused on Orford Reef out of Port Orford. And here's an example. This is the OG Marine Habitat team. There's Dave Fox and Arlene doing it the old school way, writing down data onto a clipboard, trying not to get sick in the back of a boat. And that set the stage for a lot of such initiatives. So meanwhile, back on shore, as part of the Territorial Sea Plan process, Part 3, there were sites that were recommended in 1984 for designation under for different categories of rocky shoreline protection. And the program collected aerial photographs that mapped the extent of these areas, but a lot of the real on the ground driver informing some of the understanding of those communities was an intensive rocky shores inventory that was done in 1993. So this was a collaborative project with OIMB. Summer class students were trained up in identification, and the team fanned out across Oregon's intertidal zone. And this was a major baseline data collection effort that really set us on a solid footing for understanding what those areas, and were relayed into the recommendation of many of these sites for the TSP3 process. This work was supported by Bob Bailey at DLCD in the Coastal Zone Management Program, who was a great supporter of this work and additional work on subsequent work on the Rocky Reefs. It culminated, well, one of the products for this was this really nice guide to Rocky intertidal habitats. If you haven't seen it, I highly recommend that. It sort of represents a baseline that I hope that one day that we could return to and look at change in these areas across these 30-some years since that was done. Okay, continuing on this nearshore data collection theme, the project was involved in a major effort in the late 1990s to document the biomass and distribution of bull kelp at major reef systems along the south coast. That was in response to some proposals for commercial harvest. It was determined that there was not sufficient biomass to support that harvest, but that really set the stage for our understanding of abundance at many of those major reef systems. Our team was involved in not just the aerial surveys, but here's a young Bill Miller who's actually collecting, sampling kelp, weighing out the different portions of that. And so that's a really nice foundation of some of our modern understanding. Along came the unfortunate incident of the New Carissa oil spill that kind of woke us up to our need to be aware of these nearshore resources and what their sensitivities might be. Also getting our preparation together, I guess you would say, and set the stage for some of the planning work that we've done over the years in that regard. So the turn of 2000 brought a new tool to the program. This was the remotely operated vehicle, the trusty Sea Cow that's been with us ever since. And this tool was something that was really, we think of it as a tool that's a way to document the distribution of, or the abundance of fish without catching them. But its early use was really related to needing to ground truth a lot of the sonar surveys that had been done. So it was used in understanding from a visual standpoint what the seafloor categories were, what the substrate types were in the early days. We'll be talking a lot more about the ROV in just a few minutes. So the sonar data that we're referring to came in an initiative that started around 1995 and rolled through at least as late as about 2009. ODFW had been involved in actually directly gathering the data, doing the surveys at the sites that you see here on the left. That had accumulated to really only about 5% of state territorial waters. By 2009, with a $5 million grant from the NOAA Office of Coast Survey, we collaborated with OSU for the State Waters Mapping Project, and that resulted in the footage that you see, the coverage that you see there on the right within state waters. So we'll talk a little bit later today about a hole that was left from that project down at Rogue Reef. The importance of the ground truth data is really key in classifying what the substrate types are, because not all the places you see hard bottom on the sonar are hard bottom. They might be things like these extensive sand dollar beds that were discovered just off of Moolock Beach here in the Central Coast. So putting it all together here, we've arrived at a point where the project has accumulated a lot of data across the years. The Nearshore Ecological Data Atlas was put together in response to, at that time, the idea of impending arrival of wave energy projects and the need to cite those things. So this was a data compilation effort across these many variables that you see here, some GIS analysis that put that together, some decision-making Mark-Zahn analysis that culminated in the nomination of areas for 3 tiered classes of protection under statewide planning goal 19 for the protection of ocean resources. So I want to just give you a sort of synthetic view now. This is an overview of where we've been, the kind of work that we've done, and you can kind of see how that's put the marine habitat projects, initiatives in place. So we talked about the core studies in the Rocky Shores in the late 90s. You can see here the three major marine reserve, the three marine reserves that the ROVs have been a central part of. The yellow large ROV there that we got in 2000 is the main one. That's the Phantom ROV. And then in late 2017, we acquired another smaller blue ROV that we'll talk about later. There were the kelp biomass surveys that were done in the late 90s, but then again surveyed just for aerial distribution in 2010, 2022, and 2024. Outside of the marine reserves, we did a number of additional ROV surveys, mostly focused on nearshore rocky reefs in other areas of the coast. So in red there, you can see Cape Perpetua and Silettes were focal sites for hypoxia work that was done in the mid-2000s. The ROV was used for scouting the locations for Redfish Rocks Marine Reserve in about 2008. We did a broad study in around 2012 along the north coast. There was a biogenic habitat survey at Cape Arago in 2015, some acoustic dead zone work, collaborating with other researchers at ODFW in 2018, and some recent work along the south coast looking at sea urchin distribution. Additionally, we've had some work offshore. So at Nehalem Bank, we studied the impact of trawl, the shrimp trawl industry, and then at Hecata Bank looked at bottom trawling just recently. So to wrap it up, we're talking about where we are from here. We just wanted to highlight a few of our priorities. Kelp data is a big current priority. We need to increase we're planning to increase the survey frequency to get a better sense of what's happening with kelp and cross-calibrate the modern methods with the methods that were used in the 1990s. We'd like to extend our use of the Blue ROV to expand repeated index sites in the near shore. We'd like to do more analysis that compares the two ROVs that we have and a new ROV that will be coming online this year. And we'll be focusing on data compilation for a number of resource management and policy purposes, including essential fish habitat reviews that will be coming up. And with that, I would like to bring Maria back up.
Thank you, Scott, for walking us through all of the marine habitat projects and introducing us to them. So you've heard a lot about these two different teams, the Marine Reserves team, Marine Habitat team, and the work that we do in the Marine Reserves, ecological research, human dimensions, and outreach, as well as Marine Habitat, a lot of their ecological research specifically, but also touching on their policy work. I want to bring us back to look at the Nearshore Ecology Program as a whole. And on the right side of the screen, you'll see a map of our activity as a program in 2025. This shows all the places that the Nearshore Ecology Program has done any work this year. And actually, this is just a sample of it too, because we'll be hearing about the kelp work later on today. On the left side of the screen, we have a big 2025 highlights as laid out by our by the numbers sheet in our Nearshore Ecology Program year in review. If you've seen it, we did a virtual broadcast of it a couple weeks ago, but if you'd like a hard copy, they're on the table right outside the double doors, and we encourage you to grab a copy. But between our two teams, we've hired 4 new staff, had a hand in several publications and reports, collaborated with 28 students, engaged with the public in 36 outreach events, provided over $50,000 to community-based programs, counted nearly 8,000 invertebrates in video reviews, and conducted research over 36 days on the coast. It's also important to point out that we couldn't do this kind of work without our local captains and fleet. We contracted with 8 vessels this year between the two teams on the Oregon coast, and we can't forget our 88 dedicated volunteers who came out with us on hook and line and intertidal surveys, which totals to over 640 hours working alongside us. So that is a lot of wonderful work that our team has done and our local fleet and volunteers. So thank you all so much for participating and being here with us to see it all laid out. Again, if you haven't gotten that hard copy of the year review, please pick one up. And with that, we have the floor open for questions for how are we with time now? For around 5 minutes. So we'd be happy to take any questions from you. We have some microphone runners that are going to come up and grab some. And this could be questions for any one of the presentations that you've seen so far today.
Okay. Hi. I was curious about the one specific thing related to the collaboration, and I'm sure this is going to reveal some of my lack of understanding, but it sounds like the Marine Reserves have a lot of work done in the social sciences, and the Habitat group was focused on policy, and those two seem to work. It's very important to have both. When you have policy and you haven't really considered the people impacts or where people's hearts and minds are with it, things don't tend to work as well. I think about like the offshore wind that seemed to fail, and maybe more people engagement would have had a different impact. So I'm curious, is that an accurate understanding that those two historically were more divided, that policy was based on the science and there was work happening in another team that was more people focused? And what's happening with that collaboration now?
Yeah, that's a great question. Our human dimensions work has been historically focused on the marine reserves. However, there's been some application for the whole marine resource program as well. I am wondering, I know that Ashley has just started with us this year, but we have both Sarah Klein and Tommy Swearingen in the crowd. So if you wanted to add anything else, or Arlene, if you wanted to add anything from the policy side of marine habitat, there's been any outreach on that side.
I've got the mic on. I'll just maybe just give it a thought on that. I guess one thing that might be helpful to clarify is when we refer to policy input, most of that takes the form of responsiveness to initiatives that that we're providing state agency comments on. So a lot of it is comment letters. We generally don't have permitting authority. We're often writing letters, for example, things like the Army Corps nationwide permits that cover marine aquaculture and that sort of thing. We're often writing letters for that. So marine habitat has taken the sort of attitude of, we are representing the agency in terms of looking out for the resources and providing comment on those. We haven't been on the policy front developing policy and sort of pushing policy. So that may be a distinction of the sort of where we've worked. Yeah.
Yeah, hi, it looks like you've done some work on kelp beds, aerial surveillance and this sort of thing. Can you say a word about how you're coordinating with other folks like Orca, the aquarium, for projects like restoration or kind of more detailed analysis of what's the dynamics of the kelp bed health is and things like reintroduction of the pycnopodia?
Sure. We'll be talking about our kelp surveys later in the afternoon here. But just quickly, at the moment, we're actually collaborating with Orca on planning for a survey that'll come later this fall. So we're directly working with those folks on that, and we've been engaged in reviewing their permit applications for much of the in-water work that they're doing now. So ODFW has been in a position to be able to creatively kind of address the historical mismatch between the kinds of permitting that have been available in the past for in-water work related to sea urchin management and interaction with kelp, and really help create the infrastructure, the permitting infrastructure for them to be able to do some of that work. So we've been very engaged in on that front. Moving forward, we expect there'll be a whole new level of discussions about pycnopodia and the reintroductions. We've been engaged, staff has been engaged in that process. It's not just necessarily marine habitat, but other shellfish program staff are looking at those issues. So we're definitely actively part of that conversation. Get a microphone over here.
Okay. I can't help
guess
myself.
maybe should we? Okay, yeah, go ahead.
I can't help myself but ask this question. ODFW is going to, with the passage of House Bill 4134, receive a lot of new resources to address nearshore conservation strategy, species and habitats. And I'm curious if that's sort of reflected in what you were looking forward in some of your slides up there, or if there's other things that's on the hit list of stuff that you wish you could do that you never had the resources and capacity to, but maybe that's going to change.
I'll address that just very briefly. Yeah, the wish list, the hit list is very long of upcoming needs. I would not say that the recent passage has changed. I mean, it hasn't been reflected in changes here. We haven't heard anything from our leadership yet about what that will actually mean within the marine program or for our program. But I think, you know, our priorities have been marching along at the things that are low-hanging fruit, imminent issues. The whole, you're going to see the theme of the kelp, sea star, sea urchin dynamics in the nearshore, filling in our database for that, being prepared for future needs that may come down the road for that. So I don't see it changing the topics that we would be focused on addressing, probably integrating more tools, optimizing our sampling, that sort of thing. Yeah. But I'm anxious to see what we may be able to do. Thanks for the question. I think we probably need to call it with the questions for right now. Feel free to keep it up at the break and after the session. So this is, okay. So we are at the point in the program where I get to introduce you to the ROV. I'm going to give you a quick introduction here, and then we're going to show you some videos of what we actually capture, and we'll be playing videos at the break. So as you saw, the ROV is kind of the core tool that links the Marine Habitat Project and the Marine Reserves Project. So what we work with here is two different ROVs. We have the very large Sea Cow Phantom ROV, is very large, very stable, too large to be deployed on our agency vessels. We need to charter vessels, and that's been a major constraint for our work over the years. In response to that, in 2017, we acquired this small Blue Robotics ROV, which allows us to go out on our own agency vessel and deploy it just by hand over the side. In the old days, there's Dave Fox, very proud of his new toy in about 2000. The ROV was looking really slim when it just arrived. We've since bloated it with a bunch of other electronics and devices, that sort of thing. But they got great footage. Here's a 2000 image from Cape Perpetua documenting for the first time what that reef really looked like. Here's what the Sea Cow has come to be. It extra lights, downward cameras, altimeters, lasers, the whole 9 yards. We deployed it in a trailer that gets craned onto the back of a fishing vessel and has the whole control equipment in there. The basics of how that operates is essentially that it's live boating. So it's attached to the vessel with an umbilical, flying slowly along the sea floor at the same pace as the vessel on the surface. There's a suspended clump weight that does the job of dragging the umbilical mostly through the water with 50 meters of free play where the ROV can fly over the bottom and up and over obstacles. It works from about 18 meters depth to 300 is the max depth. And we have a real-time position that's communicated via a hydrophone and a pinger on the ROV. So the Blue ROV setup we can just deploy by hand out of a boat with a crew of 3 people on our own vessel, so that we can go out at very little cost and deploy that. The Phantom ROV, it was a tough year in ROV world. 2025 was the last year of the flight of the Sea Cow. So we are very much looking forward to the arrival in 2026 of our new Deep Ocean Engineering L6 ROV. It was supposed to be here by now, but it's a little delayed. It's going to give us great technology, fiber optic communications, and high definition video transmitted to the surface. So I'll just give you a little snapshot of what we see. We have 2 main cameras. There's a forward-looking camera that's 30 degrees below horizontal. That's the main view of the seafloor. We also have a downward view. And then we also have 2 stereo cameras that let us get actually quite precise sizes of objects in that field of view. So those are a little bit of an overlapping field of view. The data, the key thing, I mean, videos are great, but we're really after abundance and density information about organisms that we see. So we review the video, we count organisms, it's all time tagged, and it's related to the position along transect through that time tagging. So the combination of the time tagging of an observation plus the GPS position from the vessel and the relative position of the ROV gives us a geolocated fish. And that is just the numerator of the ratio that we're looking at. The other part of that is the seafloor area. So we have lots of data streams that tell us about the attitude and position of the ROV that go into calculating the transect strip width. So we combine that with the GPS record of the vessel and the position of the ROV to give a total sampled area. We divide the counts by the area to get densities of fish. And that's what makes this tool really comparable to other sampling tools, is that we don't just have a count from one tool, we have a density that we can compare with other kinds of data streams. So we then can take those observations because they're geolocated and put them in a GIS and analyze their positions relative to their environment, derive other characteristics of the seafloor, and create these abundance models and habitat occupancy models that are really kind of the core of what we are after. And just reflecting the passage of the trusty ROV, it has sailed its last voyage with us this year, and wanted to remember its great service. So meanwhile, I'm going to show you some videos of what we actually see on the seafloor. It's break time. I invite you to come down and you can actually check out the technology yourselves and ask questions, and I'll tell you anything you want to know about the operation of the ROV. We'll have a 15-minute break. Maria will ring the bell with 2 minutes to go, and please make your way back into the auditorium at that time. Thanks. Okay. Only, okay, so much.
All right. Cool. I think we're going to get started again. Thank you all for joining us today, and for those online, thanks for tuning in. My name is Ryan Fields. I'm part of the ecology team with Marine Reserves Program, and I'm going to be talking a bit about some preliminary trends in our catch data from our hook and line survey, as well as trying to put what I show you today into the broader context of some of the expectations that we've had for change by the different reserves. Oh, right away. Here we go. Will that work? No. Wait.
Oh,
No.
not the wheel.
Maybe we could just restart it. Stand by while we figure out some technical difficulties. Oh, maybe they can't see it crashing.
Right, we didn't need two of those.
Not quite. There.
Oh, well, they get the nice. Do you want to? Let's see.
All right, let's try that again. All right, we're back. Hook and line survey. It's one part of the Nearshore Ecology Program. Just a reminder that broadly the goals from Oregon's marine reserves were the conservation of key habitats and biodiversity to serve as research reference areas and to avoid significant adverse impacts to coastal communities. So each of our marine reserves is unique not only in when it was implemented, but also in its size, the oceanographic conditions at each reserve, a range of depths, the habitat composition, and importantly, what historical fishing pressure existed. And so because of these different baseline characteristics, we can treat each marine reserve as something of a unique case study, which just means that we have some nuanced expectations of what change might occur and when we might see that by reserve. Today, I'm going to be talking about the reserves highlighted in the red circles. In the middle there, Otter Rock. That's too shallow for our hook and line survey to talk about today. Mo did a really great job at outlining some of the main survey tools that we use up and down the coast to collect our long-term monitoring data. I'm focused on hook and line today. It's one of our longest running surveys, and so we have kind of the most robust data set for fishes. Briefly, this is a catch and release program. We work closely with local captains and volunteer anglers to collect data on sizes, species composition, and relative abundance of nearshore fishes. We survey both inside and out of the marine reserves and across time. Each of our marine reserves, we've selected a pair of comparison areas that we tried to match as closely as possible with some of those characteristics like depth and habitat type, but they're areas that are still open to fishing. A couple other details is that we exclusively target rocky reef habitat. Early on in the program, we work closely with some of those local captains, as well as using these GIS maps to outline 500 by 500 meter grid cells, or these survey boxes, over the available rocky habitat. Each day that we go out, we randomly select 5 to 6 of these survey cells, and we try to get 45 minutes of total fishing time in each of those boxes. One of the main calculations we'll be talking about today is CPUE, or catch per unit of effort. You also hear me calling it the mean catch rate or relative abundance, but this is just the total number of fish we caught in one of those survey boxes divided by the total time spent fishing, summed up across the different anglers who are with us. Before getting into the results, I just wanted to highlight that even though the reserves weren't explicitly designed for fisheries management or enhancement, we do have expectations of how fish communities might be impacted by reserves. And so at a really qualitative level, we expect that reserve sites with lots of complex habitat or areas that had high levels of historical fishing effort prior to closure would be more likely to see biological change, at least in the short term. I'm going to start with Cape Falcon on the north coast. This is our northernmost and our youngest marine reserve. It was established in 2016. From this map, looking at kind of the tan areas there, that's sandy habitat. You can see kind of dominates the reserve. But there is some low relief, kind of low complexity rocky reef habitat around Cape Falcon itself. This is an area that had relatively lower levels of historical fishing pressure prior to closure, partially due to a distance from port, but also just a known lower abundance of fish in this area compared to some of the other fishing opportunities kind of adjacent to this site. And so collectively, that's led us to believe that we might be a little bit slower to detect any kind of change at this site. So this is the mean, again, CPUE, or that mean catch rate fishes through time for some of the top most abundant fish that we saw at Cape Falcon: black rockfish, kelp greenling, and lingcod, top to bottom. A couple other details just to interpret these figures is that bold black line is going to be the trend of the marine reserve through time in each of those panels, and those blue and green lines are going to be those comparison areas that are still open to fishing. And so consistent with that expectation of a little to no change at this point in time, we do see some year-to-year variability, but really no consistent trends through time. Next, going south along the coast, this is just south of Yachats. Cape Perpetua was established in 2014. This is our largest marine reserve by area, but it also has the least amount of total rocky habitat by area. However, the rock that is there is in these kind of deeper water isolated rocky reefs, and it is known to support a large biomass of groundfish species. This is an area that had moderate levels of historical fishing pressure prior to closure. And so combined, it's led us to believe that there's sort of a moderate probability that we would see some sort of biological change at this point in time. This is probably one of my favorite figures to get to talk through today, and these happen to be some of my favorite rockfish species, the brown, copper, and quillback rockfish. These are all benthic species, so it means that they're pretty closely associated with the seafloor. They have small home ranges. They're not expected to move around much during their entire life, so they might spend their entire life, say, within the boundaries of the marine reserve. And in 2022, we saw this pretty sharp increase in the mean catch rate within our data, and then we went back and sampled in 2024. We saw that pattern had kind of sustained itself through time. We still think this is too early to really attribute this, say, to either marine reserve protections or just to the environment, kind of favorable conditions for these species. But we will be going back this summer here in 2026, and we're pretty excited to check in on these three species again. Next, I'll highlight Cascade Head. This was also established in 2014. This is just north of Lincoln City, and Cascade Head Marine Reserve protects the northern and mid portions of the Sluts Reef System. They are shown in that dark red. The Sluts Reef has a broad range of depths and habitat complexity, and this was an area that supported pretty high levels of fishing pressure prior to closure and continues to experience high levels of fishing effort in the reef areas to the south of the reserve today. And so because of that removal of that high fishing effort within the reserve, this was one of the reserves that we sort of had the hypothesis that it might be more likely to show some sort of change in our data, at least in the short term. I'll direct your attention just to the top panel at first, which is black rockfish, which are our most abundant species across the reserves, but that's especially pronounced at Cascade Head, where by far we catch a lot more black rockfish inside the reserve compared to out, and that's been the case even since before the reserves went into effect, suggesting that there's something maybe about the habitat or environment that's pretty favorable for that species at that site. And then looking at that final year of surveys across all three of these species, the other two again being copper rockfish and kelp greenling, we saw this slight increase for these species in that final year of data. With only that 1 year of a pattern, this is still way too early to lean too much on that. But this is another site that we're going to be surveying again here in 2026. And again, are pretty excited to kind of follow up with and see what happens for these species. Last, I want to go to the south coast to Redfish Rocks. This is just south of Port Orford. This is our southernmost marine reserve and also one of our oldest, established in 2012 along with Otter Rock. Also encapsulates a really highly complex rocky reef system, has emergent rock, supports a lot of diversity there, and this is an area that had high levels of commercial groundfish fishing prior to closure, and still pretty moderate levels of that commercial fishing effort in the areas around it today. And so like Cascade Head, this was a site that we had thought that there might be a greater possibility of detecting change, at least at this point in time. Despite that prediction, when we looked across some of the main species we were encountering down there, we didn't see a lot of really clear or conspicuous trends through time. There is, a year-to-year variability, and we're looking at those top two species, the black rockfish and kelp greenling. We see that some of those ups and downs through time track pretty well inside and outside of the reserve together, suggesting that they're driven by environmental influences rather than the reserve. One break in that pattern is on the third species there, China rockfish, where we have seen a pretty consistent increase through time since 2019, but it's at one of our comparison areas at Orford Reef. And that's a pattern that is matched with some of the commercial landings data from the Port Orford area. So something interesting going on there. Okay, recognizing I threw a lot of figures and species at you, but just by way of really quick recap, we did see some strong year-to-year variability in that mean catch rate, but no clear trends that existed for all species across all sites. At Cape Falcon, we didn't see any meaningful changes yet consistent with that expectation. At Cape Perpetua, we did see the strong uptick in the mean catch rate for a handful of benthic species. And at Cascade Head, we had the greatest relative abundance, at least numerically, for several species that we surveyed in our final year survey in 2024. And those last two sites will be going out again here this summer. And Redfish Rocks, still no clear patterns through time yet, with the exception being China rockfish, which seems to be increasing at one of the comparison areas. So given some of the patterns that I've shown, and as we think ahead to the future about what our expectations of change might be, I thought it'd be worth thinking about some of the factors that are known to influence marine reserve systems and other places. For starters, thinking about just the species themselves, cold water temperate species like rockfish or the greenling that I've been talking about today are known to grow slow, reproduce late in life, and are expected to take many years, maybe even decades, to build up meaningful biological change after fishing is stopped. Similar hook and line surveys that were conducted in California and some of their marine reserve systems where they found positive marine reserve effects. Those are correlated with the size of the reserve, its age, and how much external fishing pressure continued after the reserves went into place. And just a quick note on how the environment might impact the reserves. We know that wide-scale marine disturbance events, or like marine heat waves, are expected to increase in size and frequency with climate change. And if we think about marine heat waves in particular, like the blob years of 2014 to 16, that had really wide-ranging impacts on the nearshore environment that, of course, included marine reserves. And there was a study that suggested that the time needed to detect change in reserves could be reset to some extent if it was impacted by some large heat wave type event. So I think it's important that we think about these factors and others as we set expectations for ourselves of what change we may or may not see here in the future. So I think this is still kind of preliminary data, but we hope that additional explorations, we can involve other factors such as oceanographic variables to help explain what patterns we might be seeing. And I think this also highlights the importance of long-term monitoring. You can see how variable sometimes the data was just year to year, even in the early years. And this helps us understand what that baseline variability is to help us detect meaningful change through time. Okay, I'm running out of time, but I wanted to, again, sympathize with you that you had to sit through a lot of different species and figures, but I would invite you either through this QR code or library or email me at any time. We have what we're calling our data dashboard available online. You can select a reserve, a survey tool, and species and recreate all of the figures that I presented with you today, spend more time with it, as well as look at species that I didn't get into today. And then one last QR code for our latest Hook and Line newsletter. We do get into a little bit more detail into some of the stories that I presented here today. And with that, I'm going to pass it over to coworker Stephanie, who's going to talk about some of the volunteer aspects of our Hook and Line program. Thanks.
Ryan, you're using this? There we are. Thanks, Ryan. Good afternoon. As Ryan said, I'm Stephanie Fields, no relation. I'm the assistant project leader with the Marine Reserves Ecology team. And I'll be wrapping up our session by highlighting the contributions of volunteers and fishing captains to our Hook and Line data sets. Also touch on some of the outreach and engagement elements of our Hook and Line surveys. And then I'll also show you how to get involved if you are not already or interested. In case you were lost, here is the figure to reorient you. We're going to be still focusing on Hook and Line surveys, but touching on outreach and engagement. So first, I wanted to walk us through a day on a Hook and Line survey. Ryan just highlighted the end product of our survey, but there's a lot of human effort and coordination that goes into collecting that data. So first, we need our research vessel. So every year, we contract with local charter fishermen and have an open bid process for them to put in a bid for a contract for us. Once we have that in place, we have our vessel and captain and crew. Then we'll need some of our Marine Reserves ecology team staff to coordinate the trip and also lead the trip on the day of. We do all the fish processing. And then we have 10 volunteer anglers on every trip. And so these are our volunteers that catch all of the fish for us. And then last, we have 1 to 2 volunteer biological assistants. And their role is to record the data that ODFW staff are saying or maybe yelling aloud. So for a trip to happen, we need about 12 volunteers, our captain, crew, and vessel, some good weather. And this coming year, Ryan mentioned our upcoming year will be out of Cascade Head and Cape Perpetua. We'll have about 20 field days, so we'll be working hard to fill around 240 volunteer positions. So first, I want to highlight our captains. We worked with charter and commercial captains since the beginning of our surveys. And they've been a core part to the success of our data collection, as well as getting us home safely. They've also contributed more than just being a research platform. They've contributed their local expert knowledge to help guide our survey development through time. Oops, here we go. So this is the map Brian had up of the Cascade Head Marine Reserve in red. Those boundaries are put into place through an intensive community process, but the green areas are comparison areas that are similar to the reserve but still open to fishing. We're up to the agency to determine. And one of the factors that went into that was our local knowledge from our captains. So zooming in on the Cascade Head Marine Reserve, these are our fishing cells, and so captains also had helpful input on the final position of these cells. So they were selected through a random stratified approach, but also involved captain input. And beyond Hook and Line surveys, they've helped guide the construction and placement of our oceanographic moorings, as well as down near Port Orford. We developed a supplemental longline survey with a commercial captain down there for the Redfish Rocks Marine Reserve specifically. So with that, I don't think we have any captains in the audience, at least in person today, but I want to give a big thanks to all our captains. A lot of them were part of the process of establishing the reserves. As I mentioned, helped us develop our methods through time. Thank you to any captain or charter office that navigated state contracting. We couldn't have done it without your commitment to that process. and for sharing your perspective on both our methods and data through time. So now I'm going to focus on our volunteers. So as I mentioned before, our volunteer anglers are the ones catching the fish for us. And this is a volunteer position that we require previous ocean fishing experience for because we're fishing for science, not just for fun. But as you can see, we try to have a good time out there. So if you're interested in coming out with us, we do have fun. And then we have our volunteer biological assistant role. For this role, we don't require any previous experience. We just require a 1-hour virtual training every year. So if you're interested, we'll be doing that training coming up in April. And this is just so we can get people, provide clear expectations for the day, how to prepare to come out with us and get them used to data sheets before we're out on the boat. This is a good role to gain experience at sea, if you're interested in that, and see if you like working on the Oregon Ocean. It's not for everyone, as you can see. Some people love it, up in the far left corner there. And not pictured here are some people that maybe had their first and last day at sea, but they still promised they had a good time with us. Yeah, I think it's a good experience if you're wanting to know if you want to follow a path on research vessels. So our volunteers contribute a lot to us, including getting to us on the coast. So they come from near and far. So this is a map of Oregon. I just highlighted the main 3 ports we go out of with volunteers. So we go out of Garibaldi, Sample Cape Falcon, Depot Bay for Cascade Head, and Newport for Cape Perpetua. And the blue dots are where volunteers are coming from. So we do have a good cluster on the central coast and some up on the north coast. But we have people also coming from way down south, the valley, and even Bend to come help us with our surveys. And I want to quantify an estimate of the hours our anglers have contributed to our program through time. So here you have total volunteer angler hours per year. As you can see, they've been involved with our survey since the beginning in 2011. Since then, they've filled 1,800 volunteer positions. So that's a person on a pole to collect our data. They've contributed over 14,000 hours to catching fish for our program. And I just want to highlight that does not include travel time. That's just time out on the boat. And in total, we've caught over 30,000 fish for our database. So thanks so much. Couldn't have done it without you. And then just for a summary of our latest year, last year in 2025, we were just going out of Garibaldi to survey Cape Falcon. So just for that one reserve, we had 73 unique volunteers fill 114 positions. So yeah, we couldn't do without them. So thank you. I know we have volunteers in the room today, I think also online, but we really appreciate everything you've contributed to our program. You might have noticed that we have fewer volunteers per year than we do have positions. We also rely on what we call our core volunteers, which are people that are able to come out many times a year, some even every survey if we need it. We have that balanced with people that come out, for their annual survey with us, as well as new volunteers every year. And just personally, this is one of my favorite parts of my job, is getting out on the boats and seeing both familiar faces, catching up on how things are going, and meeting new people and talking about our reserves with new perspectives. So I'm going to wrap up just touching on some outreach and engagement elements of our Hook and Line surveys. They're essentially built into our Hook and Line program and essential to building connections and trust with our volunteers and crew. For one Hook and Line trip, we have 8 hours with our volunteers and crew to chat about anything, including marine reserves. Generally, we also get a lot of questions beyond our expertise, maybe more on the fisheries management side of things about quotas and stock assessments and things like that. So we do our best to connect volunteers with other ODFW staff that can answer those questions more exact than us. For example, this volunteer photoed here, I'm very excited with this rock that he caught. First came out with us in 2024 with lots of great questions, both about marine reserves, but also about broader fisheries management. Our team made sure to follow up with him and connect him with the best staff to answer the question. So thanks to Christian Heath for helping with that. And then he came back out on the boat thanking us for taking him seriously, and then enthusiastically drove up from the South Coast to help us on the Central Coast for many more surveys, usually with peanut M&Ms in hand to share. So I think just an example of our efforts, and sometimes we get to see the actual results of that engagement. Our team focuses a lot on improving communication through time. We're always chatting and debriefing about how to improve our communication and answers to questions in the future. We also bring out little info binders with us for volunteers to read through or for us to reference in our discussions. And at the end of every year, we debrief with our captains on how things went, but also share our data to get their take on emerging trends. And as you saw, our volunteers contribute a lot to our program, so we try to make sure they feel thanked. So every year we have a hook and line patch. So you can see a volunteer here with his collection going on his jacket. So every year we have a new fish. So if you come out every year, you get your new patch. And we also have stickers for the reserves you've helped in. You can try to collect them all. And then as budget allows, sometimes we have some extra bonus thank yous. And then our major outreach component of our hook and line surveys is our newsletter, which I think multiple coworkers have touched upon. So our 2025 newsletter marks our 11th annual Fish On Hook and Line volunteer newsletter. And so at the end, also if you want to use, I think Ryan had it on his too, but there's a QR code there if you're interested. It's also on our website under the resources tab. But at the end of each survey season, we process all of our data, and we put together this newsletter that has some high-level data summaries, as well as dives into specific stories from the reserves we sampled that year. So this year we have a spotlight on Cape Falcon and a unique feature there, a sunken barge. As Ryan mentioned, and if you wanted to read some more about our thoughts on it, we have some interesting trends in China rockfish in the Redfish Rocks Marine Reserve area, as well as some oceanography summaries looking at oxygen trends across years at both reserves. So with that, thank you for being here today. Ryan and I will take questions in a second. I just wanted not to overwhelm you with QR codes, but this one is how you can get involved. So we have a new tab on our Marine Reserves website, Get Involved. And so this one will take you straight to the volunteer sign up page. So it'll go over both the volunteer positions I talked about today. And then there's also another option. If you want to come out with us and stay on land, we'll do intertidal surveys at the Cascade Head and Otter Rock Marine Reserves come June, July. And so you can read about that role and what to expect. And then there'll be a link to a ODFW volunteer form. And you just have to fill out that form, and then we'll get your info and you'll be signed up and part of the communications as we plan our upcoming 2026 field season. Thank you, and we'll take some questions. I think they need it.
I gave away my.
They need to.
Great.
Thanks. This is really exciting to see this compiled. I have a question about the comparison areas and whether there is documentation either in the newsletter or elsewhere in the reports about other things that might be affecting that kind of baseline condition in the comparison areas, whether you're accounting for other factors, like I'm thinking specifically about subsea cables or dredge disposal or proximity of those comparison areas to other effects that might be part of that relationship between the comparison areas and the marine reserves.
Yeah, I think we have some of that, but not at the detailed. Yeah, dredge and cables. I'm not sure. I mean, one of the goals of us having like multiple comparison areas was to like also buffer against some of those variables. And of course, yeah, we can't match, one-to-one in terms of what we had there. But I'd be happy to look into that a little bit more and follow up with you if to what extent, yeah, we've detailed all of those extensive, comparisons or differences. Dave, did you have a thought about that too, or is that another question? Yeah. Maybe you can.
Thanks, Bill. Kind of building on Delia's question, because I was thinking about that too. I was kind of struck by the increase or apparent increase in China rockfish at the Orford Reef comparison area. And I'm wondering if you're correlating like commercial fishery data, like has there been a change in China rockfish catch at Orford? I know that was heavily targeted in the live fish fishery for years. And I don't know if there's been a decrease over the years, and maybe that could account for an increase in that species.
There's a lot of little details with that it would be great to track down in terms of why we're seeing that pattern. I think in the commercial landings data, though, there is evidence that they've seen an increase as well in like the live fish fishery at Port Orford. So that seems to be a pattern that's corroborating what we're seeing. I think anecdotally, it seemed like some of our captains talked about seeing an increase as well in terms of the underlying, reason for that, whether it was changing regulations or fishing effort or just a good recruitment at the broad, Orford Reef or something. Not totally sure, but we'd be excited to look into that more.
Can everyone hear me okay? Yep. Welcome. Yeah, my name is Dylan Gomes. I'm the new quantitative ecologist here with the Marine Reserves team. And the work I'm going to talk about today is in this top right quadrant again. I want to start by just briefly, asking why we should even care about biodiversity in the first place. I think it's intuitive to a lot of us, but species around the globe provide all kinds of ecosystem services to us that offer both indirect and direct benefits to our well-being and our survival. A really obvious one in the ocean is we get a lot of our food from there. And unfortunately, we're in the midst of the Earth's 6th mass extinction, and so we're losing species thousands of times faster than historic rates. And so this is a major problem. A lot of different areas around the world have decided to protect areas of the ocean and obviously on land as well. And we're talking about marine reserves today. And so some of these ideas are in response to catastrophes like that, as well as other environmental sort of issues. And before we can talk about diversity, we should also probably define it. It can mean many things. Often in ecology, we're talking about species diversity when we say biodiversity, and that is, you go to a habitat, you look around, you start counting things out there, and you're sort of separating them, if you will, from their interactions in their environment, and just saying this is one species, this is the next one, and you're counting them. And when you start counting them, that is called species richness. And I'm going to explain briefly why species richness isn't enough information. And so if we imagine there's two different communities divided by this vertical blue line, this community on the left and this community on the right, they both have the same exact species in them. And so the species richness is the same across those. But this community on the left is much more balanced. So there's a more even number of individuals than there are on the right. And so you can imagine the one on the left might be a little bit more robust. For example, if you lose one sea star, one individual sea star from each of these communities, all of a sudden you're down one species on the right. And so species diversity takes that richness and it incorporates basically evenness into it. And so again, on the left here, we have higher diversity, and on the right, we have lower diversity, even though richness is the same. There are other types of diversity, of course. We can think about functional diversity. So what role do those organisms play in their communities, as opposed to thinking about individual species? There's genetic diversity. And so we think about this a lot with salmon. Genetic diversity leads to differences in run timing, which in a changing world with a lot of intra-annual variation in conditions becomes really important for population survival. Another one is structural diversity, so we can think about the actual three-dimensional structure of a habitat and how that might be different over space. And so this is just a few examples of diversity. Today, we're really going to focus on that top one, that first one, species diversity. So you have seen this a few times already from other members on the ecological team. These are our core tools here, and those in combination with some of our collaborations. We've got these 6 different data sets across the top that we've put into a biodiversity analysis. And so just to kind of run through some of the organisms that are coming out of these surveys, we just heard about hook and line and long line that are providing information on fish. The ROV also provides information on fish as well as invertebrates. Same for scuba, but in addition, there are some algae surveys there as well. And then the SMRF provides, again, information on fish, but a different life stage. And then we have these intertidal surveys that provide more invertebrate information. And so then we take all of these data on these different organisms, and we're putting it into basically one analysis to try to understand biodiversity in and out of the reserves. So just to give a bit of an idea of the spatial, temporal scale and sort of the magnitude of effort, I'm going to walk through this briefly. So on our y-axis, we have our labels for different marine reserve areas starting by year of implementation. So we have Redfish Rocks and Otter Rocks at the top, and then Cape Perpetua and Cascade Head, and then Cape Falcon at the bottom. And then this is looking at basically effort across years. And so the actual color here is how much effort went into that survey in that given year. And so in the case of hook and line, that would be the number of drifts. We don't need to focus, I don't want to bog anyone down on all of the specific details here and overwhelm you with a bunch of colors all at once. But I just want to show that we have a lot of different surveys that are across different years and in different sites, and we're pooling that all to try to understand biodiversity on a bigger scale. And so this is a tree of life or a phylogeny that I've created with a lot of the species that we've got, and these are organized by genera, so not the individual species are sort of collapsed into one, with some silhouettes on the outside. So we've got a lot of different information on different organisms from algae to fish and inverts, and specifically we've got 271 species or species groups. There's a couple of different species that are grouped together because they're difficult to tell apart. Across 122 families, 77 orders, 28 classes, and 14 phyla. So it's a pretty diverse data set. And I'm going to return to this figure I showed earlier with these 2 different communities because I want to talk about an idea called coverage. So if you were to randomly sample individuals from these different communities, just by chance, with a more even community, you're more likely to detect all of the species that are there because they're evenly distributed. Whereas if you have a community that is dominated by one species, you're more likely to sample that species. And so there's this idea called coverage where we can actually estimate the total number of expected species there depending on how that sampling goes. And so you can just see that in different types of communities, we might expect to actually get lower or higher coverage just depending on how they're structured. And so equal sampling isn't always actually equal in trying to determine the number of species in a site. And so on this plot here, on the x-axis is that coverage, right? So as we go from 0 on the left to 1 on the right, you can also think about that as 100%. We have more and more coverage of that community. And then on the y-axis is species diversity. And so as we get higher coverage, species diversity increases. I think this all makes sense. What's pretty cool is that marine reserves here in red have higher species diversity, again, in aggregate across all sites, all years, than our comparison areas. What's also really cool is that we're estimating, given our survey methods, we're estimating that we're at about 99% coverage. So there's not a whole lot more that we're going to detect. And then the more classic way to look at these curves are species rarefaction curves, where you have the individual sampled or sample size on the x-axis. And this is showing the same information, same trends. But a question we have, right, is were the marine reserves always more biodiverse? Did we put them in sites that were more biodiverse, or does this have something to do with the closure, or what is actually going on there? And so instead of having just a comparison between the two, what we actually want is something like this, where we can look at pre-closure, where fishing was kind of allowed everywhere, and post-closure, where fishing is no longer allowed in marine reserves. And so I'm going to show some plots there in a minute. I just wanted to set that up. And so I'm still keeping the same colors. Red is for marine reserves, but I've used a darker red for the pre-conditions, the pre-closure conditions. And so I'm showing the line there that you'll see in the next figures. In same blue again for comparison areas. And so if we just look at the pre-closure conditions between comparison areas and marine reserves, you might not even be able to see that there are two lines there. So this is pretty cool because it's suggesting that our marine reserves and our comparison areas, although they might not be the actual same communities, right? This doesn't say that those are the same individual species. They have a really comparable number of species. So that's pretty exciting. And now I'm going to add the post-closure curves here. And you can see that in the marine reserves after closure, there was an increase in species diversity relative to the pre-closure conditions. And with the post-closure comparison area, there is a decrease. And so this says preliminary results across the top because we're still actively working on this. It is worth taking this with a grain of salt. There are a lot of differences in detectability across surveys that we need to control for in a more like advanced hierarchical model to see if these results hold up. And of course, there's all kinds of things happening in the ocean all the time. So it's complicated, but if these results hold up, this is really exciting. So what to take home from this? One, marine reserves have higher biodiversity than nearby comparison areas. And this seems to be a pretty robust result across different ways of looking at it. Species coverage of our surveys is estimated to be very high. And I have surveys asterisked here because this doesn't mean we're detecting 99% of species possible in our reserves, right? We have survey methods that don't sample for bacteria, for example. But it's specific to the surveys that we are using. We do think we're detecting just about everything. Also, the marine reserves appear to be comparable to comparison areas prior to closure. That was what folks were shooting for when they set these up. I was not here for that. So that seems to be a job well done, at least in terms of biodiversity. And then lastly, the marine reserves appear to be affecting biodiversity post-closure compared to the comparison areas. So pretty cool. A lot of people have contributed to data for this analysis and thoughts and ideas, and so I'm listing some of them here. A lot of people to thank in our team and as well as external collaborators. So with that, I can take any questions. I don't know how much time I've got for those, but.
Are you tracking the biodiversity of the native species versus the non-native species versus the invasive species, or is it just all species in general? And if there's any invasive species, are you doing anything about them?
Good question. Good question. We have not been looking at native versus non-native. I think that's an interesting idea. Yeah, and we're not specifically doing anything about that at the moment. I mean, there have been talks. I mean, urchins are not they are native, but there have been talks of, what are we doing with the urchins and stuff because of urchin barrens. But yeah, it's an interesting idea. I think somewhat related to that, we are interested in breaking this up by different taxa, different taxonomic groups, and looking at different, even potentially like functional sort of guilds, like I was showing earlier. But yeah, we'll add that to the thing to think about. Thanks.
One of your figures, it showed that there was a decrease in species diversity in the comparison areas following the closure of the marine reserves. Do you have any theories as to why diversity went up in the reserve and down so drastically in the comparison area?
Yeah, I think that's a really good question, and that's why I was like, take it with a grain of salt. Nothing's final yet, but yeah, I mean there has been other work out there showing that diversity increases in marine reserves over time, and I don't know. I definitely don't know exactly, if that's going on, and if so, how that's going on in our reserves, but that it can happen in places due to all kinds of different like trophic cascades when you're removing top predators or different keystone species and things due to something like fishing, that can have trickle effects throughout the food web, and lead to different changes. And so that effect might not actually happen everywhere in every single type of ecosystem or food web. It just kind of depends on the structure and who you're taking out of it and what. So yeah, be interested to look at that.
Thanks for your presentation, Dylan. Towards the latter half of your answer, you started to get at the question I was going to ask, which is, do you know yet whether the species that are contributing to your changes in diversity are those that you would expect to change based on an MPA closure, either through direct or indirect effects?
Yeah, it's a great question, and with that phylogeny, and there's like some, basically a little section for fish, and we have a lot of different data on fish, but the bulk of the species and groups are not actually fish, and so a lot of the closure is towards fish. There was some urchin fishing and things like that too. There was some invertebrate where invertebrates are protected. We haven't specifically looked at that question yet. To answer your question, a lot of this is like new, fresh, developing, but it's a good question, and we should definitely take a look. Yeah.
Okay, I'm back. I get to talk to you again about kelp distribution along the coast. I'm going to be describing some surveys that we did just recently in 2022 and 2024, and comparisons that we made with the most recent coastal survey for kelp that was conducted in 2010. And just right off the bat here, we can see the areas where these surveys were conducted in 2010. There were the green areas mostly along the south coast, south of Cape Arago, were covered by the photographs. And then in the recent surveys, new technology, broader cameras, much wider coverage of those areas, plus some area along the central coast. So these are surveys that were targeting the canopy of bull kelp from a fixed-wing airplane flying around 6,000 feet. And as I mentioned, a dramatically larger footprint in the most recent surveys based on the camera technology, with also a higher resolution. So we have really nice, crisp, high-resolution images from these most recent surveys. And later in the talk, we'll compare to some of the earlier historical reference points that I brought up early in my introduction of the surveys that were done in the 90s that show the distribution of the kelp earlier on. We're going to be talking about the canopy area as a proxy for kelp abundance, but we know there are lots of ways of looking at this habitat and ways of measuring it. We see it from the surface here, like standing on the shore of Depot Bay and seeing the thick canopy out there in recent years. But it also, underwater, we acknowledge this is a three-dimensional habitat. It has understory aspects. It has components that are on the seafloor. So there's more to the story than just these aerial photos. The first thing we want to know about the distribution of bull kelp off of Oregon is that it's patchily distributed. There are large areas where there isn't really any rocky substrate. Bull kelp needs to grow in rocky areas. We're going to focus on many of these large reef systems that hold most of the state's kelp, particularly focusing at Orford Reef and Rogue Reef down on the south coast. So we'll be zooming in here. So here's an example of the kind of footage that we get from the aerial surveys. We're off of Port Orford here, and the colors that you see here, this is false color near infrared imagery. So the near infrared is something that picks up the vegetation. Vegetation fluoresces, and it gives us this sort of orangey color that you're seeing. We're looking at Orford Reef and Redfish Rocks Marine Reserve down to the south, and here is our 2010 survey coverage. If we zoom in here and just look at what that kelp canopy looks like, I want to give you a sort of a feel for what these systems really look like from the air. So you can see that in our imagery we have, you can see individual plants in some cases and kind of a patch level abundance. This is classified in our surveys into two separate categories. The surface kelp that's floating really above the water surface that's held in the air is very reflective in the infrared, and that's classified as surface kelp or emergent kelp. And then just under the surface, it's still visible from the air, but it doesn't reflect as strongly in the near infrared, and that's subsurface. So we have these detailed classified patches. Today we'll be talking about kelp abundance as the sum of both of those categories, so everything that's visible from the surface. So if we go first to our 2010 distribution, these red polygons are the distribution that was mapped at Orford and Blanco Reefs in 2010. I'm going to introduce in blue the 2022 kelp, and you can sort of barely see it. And I'll go back and bring that in again. So right up there off of Cape Blanco, little bits of blue. That was all that was left over that decade. What didn't appear in my intro slides was the fact that in that intervening period between those two surveys, we had a major heat wave that arrived in 2014 to 2016, another one in 2019. There was the regional extirpation of the sunflower sea star that happened due to sea star wasting disease in between those two periods. And so there's this combination of stressors that either directly or indirectly combined to influence the kelp there. The net effect was a massive increase in the abundance of purple sea urchins at Orford Reef. And our own Scott Groth here just published a study documenting the density of those urchins increasing dramatically through that period. So across the time period at Blanco Reef, we lost 48 hectares of kelp. At Orford Reef, 252 hectares. That was by far the largest kelp system in the state. And when I say lost, well, I really need to point out that this is an annual plant. So kelp distributes spores that can circulate regionally and within and between reef systems even. And so every year there's the opportunity to reset the spatial distribution of this plant, or of this algae. So by the 2024 survey, we actually saw a little bit of recovery there at Orford Reef. It's hopeful that there are some plants that really hung on through that period and haven't totally succumbed to the high densities of urchins there. Let's zoom back out and look further down the coast at Rogue Reef. This is just off of Gold Beach at the mouth of the Rogue River. And it's to date, it's the largest remaining stronghold of kelp in the state. We'll look at what that actually looks like. You can see the reef in terms of the islands and wash rocks that make up that complex reef habitat, and the kelp in orange here. Here's the classification of what the kelp looked like in 2010, and then by 2022, a better picture than when we saw at Orford Reef. So there's more of that kelp that was hanging on, but you can see the blue is overlaying the red. So red areas that you see here are areas that are no longer holding kelp as of 2022. So there has been substantial contraction from portions of that area. And then in 2024, again in yellow, an even larger degree of contraction there. So at Rogue Reef, the story is a mixed one. It's held on better than many other areas, certainly along the south coast, but has seen some declines and some shifts in spatial distribution over those years. And those shifts are something that we really want to pay attention to about this resetting of the spatial distribution each year. If you were, in terms of the bird's eye, if you were a diving bird, say a murre, here, this is what you would see under the surface at Rogue Reef. Large areas where there are very high abundances of these purple urchins, and you can see some red urchins here also. So that's sort of the visual descriptive sense of what we've been seeing. Analytically, I'm going to describe how we compare these results and look at the trends. So in the green box on the lower left is the region that will compare quantitatively across 2010, 2022, and 2024. Over on the right, you can see these analytical segments that we use. These are essentially like 5 kilometers along shore where we just created boxes and summed the total kelp within each one of those. And because those are the areas that are in common among the 3 surveys, the change since 2010 is analyzed only within the footprint of the 2010 survey. But also along the mid-coast here, we have in 22 and 24 regions that were mapped off of Depot Bay, and we'll look at those trends as well. So the results for the South Coast across the 3 years, you can see here historically in green, the very, very large contribution of Orford Reef and Blanco Reef to the total kelp across the southern portion of the state, and then the dramatic drop off there. By 2024, we had gone from 541 to 160 hectares of surface kelp. That's a 70% reduction, largely driven by Orford Reef, Blanco Reef, and Mac Arch Reef, which doesn't get as much attention down along the South Coast. So if we look closer to home, the story is a little different along the Central Coast. I'm representing the geographic break among these regions in the vertical dotted line there. So we jump from Cape Arago across the sort of the mid-coast region up to the Newport region. And you can see in the yellow bars the large increase that happened in really 2023 and 2024 in the North Coast. So we had this recent, really historic expansion of that kelp along the Central Coast. If we take that same data and we just look at it in terms of change, this is within the last couple of years, we see this really interesting latitudinal pattern where in the Central and North Coast, really north of Cape Laco, we see the blue bars. That's where we've had a substantial increase in those areas, and then a pretty grim story everywhere to the south. So coastwide, when you sum all of that, again, remembering that we lost most of the kelp in the large reefs in the South Coast, the total coastwide increase between the 2 years of the recent surveys was 26%. But we're still down substantially along the South Coast. And I think one of the key research questions is, what's the relative contribution of these different factors? We know that there's an oceanographic break. There are different oceanographic processes that change north and south of Cape Blanco. Is that explaining what's happening north and south here, or is this a story about distribution of urchins or dynamics of urchins in those areas of sea urchins? So we'll be looking at those questions as we go forward. But I want to go back and bring in this historic reference point of the kelp biomass surveys that were done on a few reefs in the late 90s. So here's the map that we were just looking at, again, back at Orford Reef. And I've put in orange on top of the previous distributions that we saw, the 1996 distribution of kelp. 1996 was considered to be a very low year of abundance for kelp, really across the coast. And you can see, even in that low year at Orford Reef, there was quite a lot more kelp remaining than we've seen in recent years. Oops, but if we just go back to, sorry, let me make sure I'm on the right side here. Here we go. We bring in just 3 years later, this is 1999, was one of the high points, really mostly coastwide, along that south coast, I should say. We went from a very low state to a very high state in just a matter of 3 years. The ability of bull kelp to distribute spores and reestablish very large areas very quickly is very dramatic. And I think the key question is going to be whether that still holds in the presence of as many hungry sea urchin mouths as we still have. Let's look again at Rogue Reef. At those historic surveys, in orange, we see the same sort of core region that was existing in 1996 in, again, a relatively low state of abundance for Rogue Reef. And then the very large expansion that happened by 1999. So it tells us a few things. It tells us we have this potential for sort of synoptic, similar patterns at different reef systems at similar timeframes, and a capacity for very large, changes in kelp, both in the positive and negative direction. Let's see if we can get that legible. We'll give you some conclusions. So just to wrap up the story, these decadal scale kelp losses are really sobering, 70% overall over that decade. But kelp is very dynamic spatially and temporally when we think about that quick 2-year increase that we just saw. As far as what that tells us about our expectations for the future of kelp here, we have this trade-off between, or this tension between the capacity for large expansions and the potential for stable states to have been established by the presence of all these grazing sea urchins, and also climate disruptions that continue to make it likely that upwelling patterns may change, provision of nutrients to the reproductive stages of the kelp may also be an influence. So there are lots of pieces here. Our work right here is really not about teasing out those differential causes. It's really about documenting the monitoring baseline and being solid in understanding of where the kelp is and what its abundance is. So if you want to read more, I think I can show you, well, the background got screwed up, but I would encourage you to go to the data clearinghouse at ODFW. We just released a report that goes into much more detail about the patterns of change and a lot of discussion about the relationship with other factors that are going on and discussion about research priorities and needs and that sort of thing. So that's out there, and I would invite any questions.
That was very interesting. Thank you. Is there any thought that changes in climate, ocean climate, i.e. upwelling, is affecting the urchins as well as the kelp, and there may be a commonality that's causing urchin population dynamics versus and including kelp population dynamics?
I think an appropriate way to look at that question is to think of sea urchins as sort of a lottery dispersal type phenomenon, where we have large recruitment events that set the stage for many, many years of that community down the line. So I'm not an expert in this, but just sort of speculating, I would say that I think, yes, those oceanographic parameters can create conditions under which a spawning event can happen. Once that's happened, as it did in, somewhere during this decade, those mouths are there, urchins can hang on for a very long time. So it may not be that we may not see a correlation of those cause and effect from year to year to year, but a one-time event that is enhanced by an oceanographic process can set the stage. Yeah.
Hey, Scott, I was curious about connectivity of spores, and do we understand the connectivity of that, like how far those spores can travel when we have such areas that have been depleted of those spores?
Yeah, thanks. That's a really critical question to understand, and we have some really good work that's been done by other researchers. I think the most interesting one I've seen is a study that considered the bimodal distribution of heights that spores are released from. So I can't think of the name of the study right now, but they looked at spores that are released from the leaves at the surface canopy. They sink quite quickly, but those leaves can be transported very long distances. So if you look at the fate of those, they're called sori, those reproductive structures, they can break off the leaves. They have abscission zones that release them, sink rapidly to the seafloor, and then those sori can be redistributed along the seafloor. So you have one mode where they go very, very far distances, and another mode where they're retained very closely. I think if I recall, it's something like the modeled results showed something like 75% of the total spore production retained within, I think it was half a kilometer from the site, but then a very, very, very long tail on that distribution. So kelp can recolonize places along the coast. And that's the kind of dynamic you would expect from an organism that's adapted to this highly disturbed, highly variable kind of reef environment.
Thanks, Scott. For your latitudinal graph, your chart, if you were to contact our colleagues to the south of Brookings or to the north of Astoria, would their data support that shift as well? Does it extend beyond Oregon's borders that things might be moving north?
Oh, great question. Well, we know one of the introduction slides that went mysteriously missing was the Northern California patterns that were documented up through the I think the early 2020s. There was a devastating loss in Northern California across this whole period. And in fact, that's sort of one of the impetus for us regenerating our interest in conducting these surveys and starting to get on our game about these data again, was the widespread loss in Northern California. To the north, bull kelp really sort of peters out for us along the sort of middle part of the state and then picks up again far to the north off the Olympic Peninsula. I am not as familiar with the northern portions, but I know from the state of Washington's monitoring efforts that their outer coast populations have been much more resilient than their Puget Sound and inner sound populations. And in fact, I think they've had some increasing on the outer straits, like before you come around Neah Bay, I think they've had some actual increases in those areas to the north. So I think it is not expected to have these same trends as you go further north. Yeah. Be glad to entertain more questions at the break.
Yeah, that's what I was going to invite more questions for Scott at the break. Thank you, Scott. Thanks for getting us back on time. During the break in the room, we'll be playing some videos created by the Cascade Head Biosphere Collaborative, but we also invite you to go out, take a break, and then when you're ready to come back in, those will be playing as well. So see you in 15 minutes. Listen for the bell.
Green light.
Okay, folks, we will come back together. And as we're getting resituated, I do want to start off session 3 with a little trivia break. So, want to ask for a C-star stress squeezy, raise your hand and then wait for the mic. Who can tell me the 2 teams that make up the Nearshore Ecology Program? Anyone? Well, not Bill.
Marine habitat and marine reserves.
Yes. Marine habitat and marine reserves are the 2 teams that make up the Nearshore Ecology Program. I should have thrown that to make it more high stakes, but okay, so now that we're feeling re-energized after our second break, welcome to session 3. I have 2 mics, that's unnecessary. You need a mic. Really want to make sure everyone online can hear me, and hopefully that didn't create some awful feedback for the people online. So I'm thrilled to be moderating this session about connecting people to place, art, science, and stewardship in Oregon's marine reserves. I should put that slide on the screen. That would be good. Let's see if it cooperates with me this time around. It does. So, yep, we are back in outreach and engagement communications land in the Nearshore Ecology Program Marine Reserves bubble, really focused on outreach and community engagement and partnership building in this section. We have some wonderful, it'll work for a minute. We have some wonderful panelists with us today from 3 of our 5 community teams. These are the organizations that help us expand our outreach, education, engagement capacity, and also our science capacity with their citizen science programs. So I'll let them introduce themselves in a moment, and really having a great time advancing these slides today. If someone wants to see if they have a better time. Oh, there we go. Okay, I just had to complain about it for 3 minutes. Okay. So we'll just have a video looping behind us. You shouldn't hear anything. So if you're wondering why you're not hearing the audio, there is no audio. But I just want to note a quick change to the agenda. We are with 3 of our 5 community team partners today. Cloud Spengler from Friends of Otter Rock Marine Reserve is unfortunately sick today and unable to join us, but we'll still have a lively discussion. And we have some folks from the Friends of Otter Rock Marine Reserve in attendance with us today. So Dennis just put his hand up back there. So if you have questions, and Mary Lean, I see you. So if you have questions about their organization, happy to connect you all after this session and during our reception. So over the year that I've been in this role, it's been really wonderful to get to work with these folks and their organizations, because they're able to use creativity to connect people to Oregon's marine reserves in ways that we wouldn't necessarily think of as the first option. And we're going to hear a little bit more about some of those examples of how they take a creative approach to their outreach engagement and connecting people with place and with science. Oregon's marine reserves are places where science helps us understand marine ecosystems and how they change over time. And connecting people to these places and inspiring stewardship often happens through different pathways. Art, storytelling, and community events, those can help create avenues for engaging people with our marine reserves and translate scientific knowledge into experiences that resonate with people in powerful ways. And today we're joined by 3 community partners whose work bridges these worlds, using creativity, collaboration, and science to connect people more deeply with Oregon's marine reserves. So now that I've spoken a lot, I'd love to introduce our panelists, starting with Angela Whitlock. So if you want to go ahead and introduce yourself and your organization, and yeah.
Yeah, really happy to be here. My name is Angela Whitlock. I'm the Marine Program Manager with North Coast Land Conservancy. We're a nationally accredited land trust based in Seaside, Oregon, but our service area is from the Columbia River down to the Silettes, from the summit of the Coast Range down to the water. And now, as we're involved with the marine reserves, 3 nautical miles out into our state waters. So really happy to be here and to share with you what we do.
We'll go to Talena. Again, 2 mics for me.
Hi, I'm Talena King. I'm the Executive Director for Cape Perpetua Collaborative. And as Katie mentioned, we're a community team and collaborative focused on the Cape Perpetua Marine Reserve. Our program area runs roughly from Yachats down to the Heceta Head Lighthouse. And we offer community engagement and education opportunities free to the public, focused on educating people on how to care for the beautiful lands that we get to live near and on.
Steal that for a second. My name is Paul Robertson. I'm the staff scientist, project and communications manager for the Cascade Head Biosphère Collaborative. We are a nonprofit 501c3 started in 2023, but really we got our legs going about 2019, 2018 even. We've got a founding member, Dan Tochel's in the audience, and Dr. Kathy Chambliss is our education director, so I want to mention those. But for those that are unfamiliar with Cascade Head Biosphere region, it's actually the Marine Reserve, the Marine Protected Area, the whole Salmon River watershed, City of Lincoln City, and it's a UNESCO site. So it's kind of a big deal for us, and we are kind of formed to bring, awareness about that designation, and of course, part of it being the marine reserve and the marine protected area.
Thanks. So excited to hear more about the examples from your work that bring science to the public. And science gives us data and understanding about marine ecosystems, but art helps connect people emotionally to those places. Why do you each think art is an important partner to science when communicating about the ocean and marine reserves? Whoever feels inspired to answer that first can go.
Hello. Okay, just checking. I'll go ahead and go first. I think that art is a bridge to some of the concepts that science are trying to communicate to a broader audience. And personally, I don't have a background in science. And so starting this work, my frame of reference was actually looking towards some of the populations that I was hoping that we might be able to reach in communicating how to care for this area and why other scientific aspects are important to implement into the way that we interact with the environment. So that's a really exciting part of our job, and what we do at the collaborative is bridging that gap and inviting people in, allowing people to have more of a sense of belonging to place by hopefully inspiring care. And as I've seen in the short time that I've been here, but also throughout my life in the Pacific Northwest, when people care about something, they are able to have a sense of responsibility for that thing that they care for. So yeah, I just find it really important to reach different audiences and welcome people in a fun and engaging way and trick them into learning about science through that method.
I can go ahead and go next. I love this question because a lot of times I think art and science are thought of as two totally different things. One is a very left-brained tradition. The other is a very right-brained, they're thought of as polar opposites. But the way I look at it is art and science both have something very big in common, and it is how we as human beings explore and conceptualize and understand our environments. Scientific communication can be very difficult for the average person, including myself, to digest. But art, I think, is a really universal language. It's something that's accessible to everybody, and it inspires reactions, and I just think it's just such a beautiful way to make scientific concepts more relatable to the visiting public when they come and visit our marine reserves.
So, I would have to agree, arts and science have been in a lot of ways kind of put on two different hemispheres of the brain or what have you, but you could raise your hands if you've ever taken a class that was in the School of Arts and Sciences. I got my degree in arts and sciences, and my stick figures are coming along, I was telling Bonch. So yeah, no skill in the art world for me, but they are interrelated, and as far as an education process, I think they have. I think maybe more recently they've kind of split a little bit. We've got really technical needs in the world. We need somebody that knows really well how to do GIS, and there's a lot of art in that, but it's a lot of technical science stuff, and so maybe that's part of the reason that we're not as studying things more holistically. But definitely the art world plays a huge role in the way we communicate, and I think that's one of the most important things about what we're doing is the communication capacity through art. We'll talk a little bit maybe about some of the specifics as well, but it's really just a method of engagement. And then I think what Kalena said is then you can hook people and then get your other messages on through that. So.
Thank you for setting the stage with that. As we've been speaking, there's been a carousel of photos behind us that show some of the ways that you all have brought art, science, and community together. Could you share an example of a project or an experience where art and science came together to tell a story about Oregon's marine reserves?
Yeah, you can go ahead and start. If you came in through the doors over on that side, you might have seen our tide pool felt board project, which is up at our table. And that was a project that came out of the necessity for a creative solution to a problem that we had. We have a tide pool ambassador program seasonally at Cape Falcon Marine Reserve. And our goal is to interact with visitors and do environmental interpretation and talk about the marine reserves to people during the summertime on the busiest times, which is the weekends and holiday weekends as well, and at the lowest tides. But last year, the busiest weekends, including 4th of July weekend and Labor Day weekend, didn't coincide with very low tides. So one of our incredible longtime marine program volunteers is a lino cut artist, and she is always thinking of creative ideas. And she said, why don't we make a felt tide pool board, and we can step a little bit back from the tide pools and have people engage with understanding tide pool dynamics that way. So we were able to teach about the splash zone, the high tide zone, the mid tide and the lower tide. And it was just, I mean, it was so vibrant and colorful. It just drew all the little kids in, which brought the parents over to the table, and we were able to talk about the marine reserves and what our organization does. And it was just such a cool thing to watch these kids. You talk to them about what kind of adaptations these creatures would have and why they would live in certain places based on their adaptations. And then they got to choose the little creatures and figure out where on the board they think that these creatures should live. Some of them thought that hermit crabs should be riding on black oyster catcher backs flying through the sky, and that's great too. It was just fun. But the best part about it to me was it taught these little explorers that they could experience the marine reserve, and they didn't need a scuba tank and they didn't need a research vessel. They could just go out and see what kinds of things live at Cape Falcon Marine Reserve. And many of them came back and said, guess what? I saw a black oyster catcher. And they learned something by engaging with us that day. So that was a lot of fun.
I love that felt board. If you guys have not seen it yet, it's really exciting. And I think that for us, one of our main and most longstanding programs has been our Tide Pool Ambassador Program. We've been leading people in the tide pools during the summer months when we have those negative tides, and we always refer to it as bringing people into outer space, that you get to see this completely different environment that is normally underwater. And so we're really privileged to be there and observe during those times. And in connection to that, we did a big mosaic project, and this now lives at the Cape Perpetua Visitor Center permanently. So you'll be able to go and take a look in person when they open back up in May. But part of the concept of bringing people together for this project was that people worked individually on certain sections of it. And so while their part in this project was relatively small compared to the whole, the whole point is that we were going to reveal and show people how these environments work cohesively and come together. And so people were really excited to be a part of this bigger thing. And we worked with a mosaic artist who is incredible at instructing people and inviting them into this skill set. And the work from start to finish with everyone's components put together is incredibly beautiful with a handmade wooden frame. And the whole point is just to communicate, that interconnectivity and why the land and sea environments and a thriving tide pool scene is actually the goal, and what we hope to see mirrored in the marine reserve right outside the window from the Cape. Do another one in the future and share that with the public and share that with people who are coming to the visitor center to learn and also just observe how beautiful it is and connect those dots that we were able to do with the participants of the project.
So I didn't prepare a speech, but I want to thank the Academy. we and our cast and crew. And so we've been fortunate enough to be able to do a lot of video work. And you got to see some of the short videos that we've been able to produce thanks to Oregon Department of Fish and Wildlife, the ROVs, our crew, and of course the cast of the species underneath the water. And so we've created 35 short videos that you can see on YouTube, coming on the ODFW YouTube channel as well. And they're just nice little tidbits, and you're welcome to take them and share them and make use of them. But they just, are just trying to like grasp some of the imagination out there and what people can't see and show them a little bit of that underwater world. And so video has been a really big effort that we've had, and we've used it in these short form videos, but we also have used it in long teaching components as well. We have a whole education program that we started with video during the COVID era, and as a way of trying to reach people. So yeah, it's a great way to connect with people, and it's very shareable and it's fun. And I think that's kind of the key. A lot of these things we just need to engage people and where they are, and if they're online, let's do that. So that's kind of one of the main aspects that we work in.
Great. The work that all of you and your organizations do is a really powerful reminder that the Marine Reserve's community goal goes beyond just reducing negative impacts and encompasses the community building and stewardship that can coalesce around these protected areas. How do you think creative approaches, whether visual art, storytelling, community projects, how can those help people feel more connected to these places or inspire them to care for them?
Well, I think inspiration is the key. One of the other things that we do a lot of times is we have these these Gyotaku fish printing. And so people go in and in fact, just last Saturday, we had a class at the Pelican Brew Pub, and, people immerse themselves in printing stuff, and they're taking in a little bit of that information about why it's important as a result. And what they really do, though, and it's kind of, I think, one of our key methods of outreach, is they take that piece of artwork home, and just like your little kid's project, you put it on the fridge or something, and everybody that comes into the house learns about that later on. And so people share that, and they're like, wow, look at this, rockfish that I printed, and here's, did you know that they live this long? And we try to infuse that kind of that enriched science effort of understanding into the art, so that people take some of that home. And again, they have that physical thing that they're taking home. So I think it gives them buy-in, and I think that's kind of really what we're trying to do is nurture that as well. So.
Sure, go ahead and go.
Anyone needs a refresher?
I love this question. One of my favorite poets, Mary Oliver, has a quote that I love, and she says, "Attention is the beginning of devotion." And that's what we try to do with our marine programming around Cape Falcon Marine Reserve, is to help folks pay attention, and eventually it inspires devotion to place. We do that through community science projects, sea star monitoring, marine debris surveys, annual BioBlitz events, hikes, our Tide Pool Ambassador program. And then in the wintertime, we've been doing a series of art workshops, which have been very popular. And one of my favorite bits of feedback from, we did a seaweed cyanotype workshop last year, people making seaweed prints. And after the workshop, this woman said to me, "I am never going to look at my beach walks the same way again." And that was my ultimate goal, is to have people pay just a little bit more attention to the place that they're in, and how amazing it is once you start paying attention, how much more there is to learn. What I do know from my personal experience when I'm engaging in art, say like art journaling, when I try my best, I'm not great, but I try my best to diagram maybe a landscape or a nudibranch or whatever it is. Once I'm done, I feel like I know it a little bit better. I feel familiarity. I feel like a kinship, a kindred, like it's a kindred spirit. Next time I'm out in a place, I feel a sense of belonging. But what that does also for folks is once you get to know something, say a specific kind of bird, by doing some art surrounding it or viewing some art surrounding it, the next time you see it, maybe the next season, it might have different plumage or it might be sitting in a different spot. And that inspires more questions and more curiosity. And yeah, so that's why I am so grateful to ODFW for supporting the creative work that we do with our community, because it feels like play, and play is fun. And when I'm having fun, we're all more productive, and it just begets more productive activities. So yeah.
Yeah, I fully agree with both of you, and just kind of echoing that same people care for what they know, and inviting people in to know the spaces more intimately really does translate into them wanting to be involved and more curious about ways to engage with caring for the spaces and participating in stewardship. And we have been doing this tide pool program for quite some time, and we are lucky. We live in a place where people want to visit. They come here all the time, and they maybe have certain traditions or certain things that they participate in when they're here. And we happen to be leading one of our tide pool tours, and a family who had a seasonal home in Yachats just happened to be at the Yachats State Park when we were leading one of our tide pool tours, and they didn't sign up. They had never heard about our organization, and they were super curious to see what we were doing with folks. And so we invited them in. They had a couple of small children, and their eyes were lit up. They were like, "We've been here 1,000,001 times, and we had no idea that this was right here," like literally steps from their door, this underwater world. And so immediately from that moment, they shadowed in on this tide pool tour. They were asking more questions than anyone else that was participating. And then they asked, how do we get involved? So we told them about volunteer opportunities. We told them about some other community science initiatives where they can help collect data. We told them about all of our programs, and it was just one interaction. And so we having presence and being able to be creative can lead people to participate as well. And they joined our next art class when they were in town. They now reach out, like, is there anything that's happening around this time frame? And they schedule around some of our programs, which is so meaningful to us because that's exactly the goal, that someone can be doing something that they love and still not know that there could be more that they could be doing to love that place even harder and leave a lasting impression. And so having creative opportunities to engage with people is so exciting. And yeah, we're so grateful for our partnership with this team to continue doing that work.
So I got the 3-minute warning on our session, and I'm going to forego my last question to see if anyone in the audience has a question they'd like to pose to the panel. No questions? One question.
Thank you. I've been a part of the process since the very beginning and helped usher in the BioBlitz effort because I got a little bit of funds from National Geographic. I think we're up to like 45,000 observations now. And it is a great fun. You don't have to be an expert. It's really good if you're a good photographer, but there's someone there that will ID it for you. So there's a list of things that really make it easy to be a part of something that is happening around the world. And we're a part of it. And then when we started it, then we got all the watershed, all of the other marine reserves embracing the BioBlitzes, and then state parks. And it is, if you haven't done it, I urge you to check it out. That's one thing that I consider just spectacular. Met some folks from Spain and totally got turned them on, just like your story. And they go, this is unbelievable what you guys are doing. We're a part of a worldwide effort. We've got to keep reminding ourselves. And the PISCO document that I share, which is so good, the Science of Marine Reserves, if you look at that insert that gets to where marine reserves, where there's projects happening around the world, there's still a gap in Oregon. I want the PISCO document to be updated with our marine reserves on the map. It's time, it's 10 plus years. So in any event, there's a number of things that are small like that, but when you share them with people, they're realizing that we're a part of something that's worldwide. That's my agenda. The question, do you know about the bioblitzes? Oh, good, so you've done them, excellent. You haven't done them, good. Well, put it on your list.
So appreciate the passion in the room for marine reserves and for art as an avenue to get involved. I'm double miking again. I don't need to do that. Get involved with our community teams. Thank you for the work that you all do to support our science through art and your various fun communication efforts. I hope that today's talk has inspired some new ideas, connections, and creativity. And during our networking reception, which I hope you'll all stick around for, you'll have a chance to explore that felt tide pool activity as well as a stamp activity to sort of build your own dream tide pool. And I'll just say that that felt tide pool board has inspired me to construct a paper mache rock to do a version of our intertidal surveys for outreach events. So I'm so grateful for this team and the ways that they inspire our own ODFW team internally with their creativity. So thank you, and we'll pass it on to Sarah.
No, I'm not. I'm just getting her mic before she says no. Okay. Step out for a second. I'll be following up.
Is the main thing, I think. Okay. Hello. It's great to be back here. I spent a year and a half with ODFW, and I really valued my time with this nearshore ecology team. And I'm now an environmental studies professor at University of Oregon. So yes, I've moved away, but I still want to stay connected. And I'm also just really glad that I was able to be part of a pretty rare way of doing science in an agency, which is to have social science and ecology and community engagement all wrapped up in one program. And I've been helping to advise these folks in California, and they have a lot to learn from what is already established in Oregon. So I'm really grateful to be here, and I want to tell you about some work that I helped to start last fall, and we're still working on it. So before I get into that, though, we're going to go to the big picture, and I am not having the magic touch. Let's see. Okay, so I want to introduce you to Kate Raworth and this donut that Kate Raworth came up with. I'm teaching a course next term about donut economics. So what is donut economics? Donut economics is a compass for human prosperity. It is a way to understand that we need to consume things and we need other people to be in community with us in order to reach a social foundation. We also need to think about perhaps constraining human consumption so that we don't get into harming critical planetary systems, and that can lead to degradation. And there's numerous ways to think about this. So there's this
ecological overshoot into climate change and biodiversity loss and many other domains. And at the same time, there's a lot of humanity around the world that is in what I would call social foundation shortfall. They're not getting enough to get into that safe and just space for humanity, that inner green donut. And we are getting, sorry, this slide advancing is tricky. We're getting into a world that's dangerously out of balance with Earth's life support system. We're getting into high risk as related to climate change, biodiversity loss, land conversion, and excessive fertilizer use. And the challenge for humanity is really to figure out how can we get more humans into that inner green donut. And Kate Raworth and her team at Oxford have a way to rethink economics. So in the 20th century, neoclassical economics, it organized itself around the individual, around maximizing individual utility with humans, particularly men, at the top, and a hierarchical understanding of humans in relation to the rest of life on this planet. And it also assumed that we could continue to grow GDP forever, even though we live on a finite planet. So 21st century economics, which is really behind this green donut, is getting at what a lot of scientists, a lot of people call the root cause of environmental problems, which is that humans don't see themselves as part of nature. And we need to see ourselves as part of nature to get at the root issues that is driving biodiversity loss. We also need to move away from the hyper-individualistic culture that we live in and think more about the communities that we live in, both human and more than human. And I won't get into degrowth right now and this idea of questioning infinite GDP growth on a finite planet. But I will say there's a lot of things we can do to improve human well-being with reduced energy and material throughput. And as an ecological economist, that's what I do a lot of research on nowadays. I also want to point you to this book, The Spirit Level, that goes deep into empirical data on how community, social cohesion, and solidarity really can underpin well-being. And those are themes that were brought up just in the most recent panel here, this idea of being part of these groups, these community groups, and can really enhance well-being. So my question here right now is, what role do the marine reserves play in contributing to well-being or diminishing well-being? And for that, we can look again to this compass for human prosperity in understanding if we are making progress towards that safe and just space for humanity, we need well-being indicators. So let me break that down. Let's start with well-being. Well-being, can be defined in numerous ways. If you think about what does well-being mean? There's lots of different domains. There's social and cultural, knowledge, health, environmental, economic, governance, and they're often overlapping. And well-being is defined in numerous different ways. So there's a lot of data linking well-being to the quality of our relationships, to service to something larger than yourself, and to having a strong sense of purpose. Let's get into the next section, indicators. So indicators are a way to measure the condition of something, usually tracked over time. And a very tricky question when you really start to think about it is, how do we track the social impacts of marine reserves? And by social impacts, I mean both the positive impacts, the negative impacts, and maybe somewhere in between, some complicated impacts. How do we track them over time? I want to bring in some critique. And I know academics, especially many critical theorists, social scientists, academics, they really excel at critique without offering many constructive steps forward. So I want to try to achieve that right balance of both helping people learn more about the critique, but then also offering ways to move forward. So James C. Scott, he recently died. He was a brilliant political ecologist, and he would say that indicators are designed for legibility. So what do I mean by legibility? states, and by states I mean government agencies, governments, state government, federal government, states need information that is standardized. States need information that is quantifiable, and indicators privilege what is quantifiable while ignoring what is not quantifiable. Indicators tend to be context blind, and they tend to, states prefer indicators that are easy to aggregate and act upon, that are comparable across space and time. So as a result, indicators simplify complex social and ecological realities. They strip away local variation, informal practices, and contextual meaning. And what the state sees is not society as it is lived, but society as it can be administered. And sometimes this can create perverse incentives. So when you come up with indicators, particularly social indicators, you have to be careful about this, because it can create indicators where people adapt their behavior to the indicator itself, and you move away from the underlying goal. So what's a specific example of this? Think about teaching to the test. If your school is evaluated by test scores, then you'll teach your students how to score well on the test, even if the broader goals of your educational system are to create better citizens. There's certain indicators when implemented at scale that can create these perverse incentives. So I won't go too deep into social science jargon here, but indicators also often are coupled with this high modernist ideology. So modernist ideology is related to techno-optimism. It's related to growing the economy indefinitely. It's related to this idea that we just need to engineer solutions to our problems. And that can be problematic. So at the end of the day, though, indicators, they are, as much as you want them to be as objective as possible, they are inherently political. They're not neutral. And for all of that, you have to be really careful when you come up with indicators. James C. Scott emphasizes that what can be easily measured becomes what matters, even if it is a poor proxy for well-being or sustainability. And indicators tend to overvalue outputs like easily quantifiable yields, income, production, and undervalue processes like care, resilience, reciprocity, ecological regeneration. So ignoring qualitative dimensions like dignity, cultural meaning, or ecological integrity can be problematic. And this can create what we call indicator bias. If something cannot be counted, it is treated as if it is irrelevant. And if something can be counted, it is treated as important, even if it's actually misleading. So with all of that context, indicators are useful, and they can be dangerous when they're treated as comprehensive and authoritative. So we don't have much time. We'll see if this works. This is an awareness test. I want you to count how many times the ball is passed from between people in the white. So count how many times the ball is passed. Count out loud. How many? White ball passing, white ball passing. Okay, this is a test of your observational skills. So I think I heard 13. Okay, did you see the moonwalking bear? Okay, let's rewind here. Okay, we're so engrossed in looking at the passing ball that most people fail to notice the moonwalking bear. Okay, so the take home here is that it is easy to miss things you're not looking for. And whenever we find ourselves intensely focusing on one thing, we may be failing to notice other things that really matter. So this is true in all models and even indicator selection, which focus our attention on some variables or phenomena, not others. Okay, I need to figure out how to. Okay, so that takes us to House Bill 4132. ODFW is tasked with coming up with consistent, measurable indicators of social impacts to conduct social monitoring data on the reserves. And This is actually a very tricky task, to try not to be overly reductionist and to really measure what matters. There's been a lot of work done in the past by Tommy Swearingen and many other people, and we decided that we needed to engage more people so that we wouldn't miss any moonwalking gorillas. So we did these focus groups. Many of you, I think, were part of them, and they were conducted up and down the coast. We asked people, we provided some background information, got people to think about different categories of indicators and then vote for ones that resonated with them. And we got a lot of different indicators. The UC Davis team that we collaborated with helped us track them and helped us categorize them. From these focus groups, we had 593 ideas on sticky notes with 1,400 votes. Then we did a thematic analysis to come up with 80 total indicators in 26 categories. And then we ranked them according to the extent to which they were supported by literature, how available the data was, how important to communities they were, to what extent they connected directly to well-being, and to what extent they had a direct connection to marine reserves. You can download this report if you're interested in it. And some of the example top indicator categories are as follows. And I'm not even going to give you the actual indicators because we still need to work on it. I was reviewing them recently, and I had James C. Scott's voice in the background telling me about the reductionism inherent in these indicators, and yet we still need to move forward. So yes, indicators are inherently reductionist. However, they are still useful, and context still really matters. So in moving forward, we will get ocean user feedback on this smaller set of indicators. I will be wrestling with the ghost of James C. Scott as we do this. ODFW and the Marine Reserves Program and my predecessor, person who comes after me, will update this Human Dimensions Monitoring Program. We have plans to field test data collection methods, learn and update the protocols, and then hopefully publish an academic paper and throughout it all, inform adaptive management. I've gone over my time, but I have to leave you with a few quotes of inspiration and a few more questions, because as an academic, that's what I do. I ask really big questions. My question for you is, what does it mean for humans and more than humans to thrive? How can marine reserves be more of a part of this thriving? And I want to leave you with a quote from Robin Wall Kimmerer from her book, The Serviceberry. She wrote, "We might step back away from the grinding system, which reduces everything to a commodity and leaves us bereft of what we really want, a sense of belonging and relationship and purpose and beauty, which can never be commoditized." So Robin Wall Kimmerer has inspired much of my research aimed at making good relationships with humans and more than humans. And I hope we can figure out how to make these relationships the currency of well-being. Thank you. I know there's some economists in the audience, so let me know if you have any questions.
Not an economist. Good to see you back on the coast. Question about well-being indicator development in regard to ocean users. I know that you had mentioned that, and the report from UC Davis was very clear about indicating how many folks from fishing communities had shown up at each of these meetings in which the initial indicators were developed, but it didn't indicate how the fishing community's needs were integrated into the development of those indicators. Do you have any insight into that? And moving forward, what's your plan of attack for your getting feedback from ocean users?
We invited commercial and recreational fishermen to come to our meetings. We had commercial and recreational fishing interests represented in the individuals who showed up. They talked with us. They provided ideas and post-its and sticker dot voting. I think that there are tricky choices to navigate around marine reserves, which are 3% of the nearshore habitat, and the costs can be perceived as quite concentrated, while the benefits are quite diffuse. So I think that there is a lot of data showing that using representative sampling techniques, there is widespread support for the current configuration of marine reserves and marine protected areas. We are entering a phase of adaptive management, and I'm sure that there will be stages in which commercial and recreational fishermen, fishing people can share their goals during the adaptive management process, which I can hand off to Maria to field additional questions related to the adaptive management process. Okay, thank you.
Okay. We are back with marine habitat again to bring us home here this afternoon. I'm going to be talking to you about some work that we did off the south coast at Rogue Reef. I referred to this earlier. And this is the latest installation of our Marine Habitat's long initiative on trying to document what is out there on the seafloor and get the basic data that we need to understand nearshore systems, the data that's foundational to a lot of this. And before I start, I really want to just shout out to Dave Fox, who's in the audience here, who was really at the beginning of this long initiative many decades ago and just had the perseverance and foresight to know that these data were going to become foundational to a lot of our work. And that has really borne out over these many years. So it was exciting for me to be involved in what I think of as one of the last big steps in this process for state waters as far as rocky reef complexes. So I refer to the fact that after that 2012 State Waters Mapping Initiative, that they did a great job of covering most of the big rocky reef systems with this one hole along the south coast. And there are a lot of good reasons for that, which is that portion of the coast, it's distant from main ports. The logistics are terrible. It's always windy. The Rogue River Bar is very dangerous, intricate navigation. So it was left kind of last on the list in that initiative. We actually tried in 2018 to get down there, and the weather shut us out. So it's been a challenge. What are we really after here? So seafloor mapping data looks kind of like this. Here's a region. This is off of near Redfish Rocks, where we have some nice detailed survey data in the upper part of that looks very interspersed with substrate classifications. And then we have some areas down sort of off of Humbug Mountain here where it's just big blobs of what we call hard bottom. And it's hard for us to know what's actually going on in that, what the depth distribution is or what the habitats might be like in that area. So what we're looking to do is collect sonar data, pair it with ground truth samples that tell us about substrate types, and apply some geological interpretation to that and get classified substrate GIS layers that we can really work with a data standpoint. This is the kind of product that I want as a field ecologist to plan a survey, to safely put an ROV in the water and navigate it around high relief features, know that we're going to hopefully get it back out of the water. You can see the high relief sort of hill shaded structures here in comparison to the different substrate types that exist there. So this is kind of the standard that we're shooting for. This is what we had at Rogue Reef, which is these big brown blobs of kind of sort of, there's hard bottom over here. The two red polygons were our target regions. And we know from the air, we've seen this image earlier, this is what it looks like from the air. And then from the water, it's a spectacular place and a difficult place to get around in a vessel. So the approach that we took to getting this done was to work out of a couple of different boats. So here, this is the agency's vessel, the Shearwater, and we ran some surveys on day trips with the equipment just mounted here on our small vessel. And then later we also chartered a commercial vessel to do some of the surveys out of. So for this phase one on the small boats, we had teamed up with Oregon State University Department of Engineering and Dr. Megan Wengrove and Hannah Glover. And they have equipment that they use for mapping actually up in the Arctic, but we're applying it here in the nearshore. It's a really nice small portable system that we can apply on our vessel. We went out and mapped off of Seal Rock to get our protocols all straightforward and all straightened out in 2023. You can see the kind of like low profile kind of nature of this device that is deployed on a rotatable pole alongside the vessel. Here's Hannah doing a sound velocity cast. That's important data to be able to interpret the sonar soundings from during the surveys. So we made 4 trips. After we did the Seal Rock phase of things, we made 4 trips out of Gold Beach and took care of basically the tricky, intricate, shallow water portion of the survey with the help of Tim Foley, who is one of the local urchin divers, who was generous in his time and working with us and helping us start to work out the coverage in the trickiest shallow water areas. So here we are in the Shearwater, following our plotter and essentially edging up along kind of tricky features and getting this very wide sonar beam that starts to tell us where we can then drive safely and work that coverage out into the trickier shallow areas. After completing that phase of the survey, we chartered the Pacific Surveyor and mounted that data. It requires all kinds of precise measurements of the exact positions of the antennas and angles and such to get it deployed. That was quite an exercise. It was a whole other thing to deal with this equipment at sea. Here we are at Rogue Reef at night deploying the equipment and making sure that we don't drop this very expensive piece of electronics into the ocean. And this technology, it's hard to communicate how advanced this technology is and how efficient it makes our operations. You're seeing a screenshot of this is the real-time data display that we had after those 4 days of small boat surveys. And you can see here, here's the track of the Pacific Surveyor as we're coming along for this second phase. And we have shadowed a bunch of areas, high relief areas on our initial survey in the small boat. And here we are in the large boat coming along, playing cleanup. We're going to come up this transect line and down the other one and cover those areas. And we can, in real time, see exactly the distribution of the data below us. So it's a really, it's a very powerful modern approach to doing this. I hate to think what Dave had to deal with back in the day on those first surveys. So in combination with the multi-beam surveys, we deployed the Blue ROV to go down and get ground truthing samples. That's going to be important later on for understanding what that seafloor looks like, particularly at Rogue Reef. There's some very complex and intricate geology. You've got all kinds of sea urchin covered features, but also these ledgy sorts of things. And so having video samples really lets you interpret what the actual classification looks like. Here's what the operation looked like on board. Here I am with the data display from the ROV. This is a real-time video while I'm actually navigating along sort of some of those shallow water kelpie areas at Rogue Reef. And here is essentially the final product of what we wound up with. So what we're seeing here is a depth, a color contour, semi-transparent overlay over a hillshade that lets you see all of the sort of high relief features in that area. So this is about 52 square kilometers of seafloor coverage that we were able to acquire. And it included a bunch of areas where we actually really didn't know that there were high relief features down here in some of these deeper edges of things. And if we look in detail a little bit, it lets us visualize where, where a lot of the more complex rocky habitats is. This is the kind of product that we can then go and layer in sampling plans for ROV or other sampling devices. We covered overall in the survey between about 75 meters depth and actually 0. This technology lets you do what they call beam steering, which is to shift the angle of the beam so that we can come up along inside an intertidal feature and map the distribution all the way up to essentially the intertidal zone in select places. So yeah, here's the overall detailed product for rogue reef, and then we take this, and then we can do things like create contour maps that gives us the total areas within different with the different depth zones, and we can use this kind of product to say create like a stratified sampling program that will represent the different depths appropriately for that region. So we feel like we're really set up for things like future kelp studies, future ROV studies, setting the stage for really learning more about that region. And then as we look toward what kinds of things can happen toward the future, I'm showing you an example of the kind of thing that you can do with these sorts of data. So here are 3D data that are showing you the relief of the seafloor with classified substrates in the different colors. We haven't done that step for this survey yet. We still need to do the interpretation and classification, creating polygons from the different habitats. But once that sort of thing is created, this is showing you examples of ROV track lines, and each one of those little colored dots is an observation of a different species of fish. So you can really start to visualize the layout of where these fish live in the landscape and their relative preferences and spatial distributions. So it's very, very powerful to be able to have these sorts of data. So I want to thank the Oregon Ocean Science Trust for the funding that got us out there. This was a substantial grant that allowed us to go do this really fundamental ecological nearshore work. Tim Foley, who guided us through the tricky shallows there. The team at OSU, who was very generous in their time and letting us use their research equipment. And I want to point out that these products are available again on the data clearinghouse, or email me and I'll send you a copy. Glad to have those get out there in the world. So with that, I can take some questions, and then we're wrapping up.
Might there be opportunities to collaborate with community groups or other artists in using your mapping products in creative ways in different contexts? I think I'm struck by the beauty of some of these data visualizations, and I think that there could be opportunities for doing that.
Yeah, I think that would be great. And I'll just comment that I think that's one of the regions in which this new Nearshore Ecology Program is really going to reap benefits, because marine habitat, at least I have not had the opportunity or taken the initiative to pursue those pathways in a way that is probably now much more accessible to me through this broader group. And so I hope to bring a lot of our products in through that level of engagement and outreach. Yeah, it's a great idea.
I like the cool graphics too, Scott. Well done. I have a question about, so the surveys were conducted kind of summer-ish, correct?
All through everything from early May through into October.
Okay.
Yeah, and at different periods. Yeah.
So do you have a sense from your time there how much of that relief would be stable versus transient? I'm just wondering how much of that, with sediment transport and sort of influx of soft bottom sediments and so forth.
Yeah, this is almost entirely rocky reef that we're focused on. There's a bunch of, there'll be a bunch of soft bottom out in the western edge of things, but so it would be, I would expect this to be quite stable in these areas. Yeah, this is a geologically very, very high relief region. Yeah. All right, thanks. I will hand it back to Maria for a wrap up.
Awesome. Thank you, Scott, and everyone else who's just presented in this session and throughout the day. Thank you especially to everyone here sticking with us through 3 sessions and a huge amount of information. We know that it was a lot to take in, but that's also just scratching the surface of what the Nearshore Ecology Program does, if you can believe that. We are excited to share with you what our plans are for the year ahead. So what's ahead for marine reserves? A big part of the coming years, plural, will be implementing House Bill 4132 mandates, including creating an adaptive management plan with everything that entails, including SMART goals, a more critical look at ecological resilience, consistently measuring social indicators, and refining our outreach and engagement plan. So you all kind of got a sneak peek at many of those issues today. As for our ecological team, we'll continue their core research, such as hook and line at Cascade Head and Cape Perpetua this year, scuba surveys at Cape Falcon and Redfish Rocks, oceanographic research at all of our marine reserve sites, intertidal work at Otter Rock and Cascade Head, and Smurf work at Otter Rock. We also have other collaborative research in the works, so make sure you're signed up for our quarterly newsletter to hear more about ongoing and future collaborations on that front. And in 2026, we'll be busy onboarding and building out our Human Dimensions team, which includes our Human Dimensions project lead, a Sea Grant Summer Scholar. This will be the first we've had in several years, and our new Sea Grant Natural Resource Policy Fellow, who will start back with us in the fall. In the meantime, we're busy publishing the Metrics That Matter work in collaboration with our academic colleagues at University of Oregon. Thanks again, Dr. Sarah Klain, for presenting with us at Oregon State University and UC Davis. In addition to the new economic studies and collaboration that Ashley mentioned at the beginning of the day, we're in the midst of discussing a pilot study survey with Sarah as well, in hopes of getting that off the ground this summer, and specifically in Newport. In it, we'd be testing out a drop-off pickup survey design that Marine Reserves has never used before. So stay tuned on ways to get engaged with that process if you're interested as well. And as for our communications and engagement plan for 2026, we're hoping to refine our goals and strategies more. And a big effort is going towards tackling the issue of signage and regulations. What I can say now is that we're working on a sign inventory to understand what's out there before trying to tackle the next steps on how to improve communications to end users. We're also going to continue outreach events, tabling, and presentations to the public, while co-developing outreach activities with community partners and underrepresented groups. Make sure that we're contacting and communicating with as many people as we can. This is also a really exciting year for the Marine Habitat team. By this summer, we should have a new ROV, so expect a slightly larger version of what you all saw today. We're also working with Orca on plans to make the 2026 aerial surveys for kelp happen. And hopefully we'll be able to continue monitoring kelp along the Oregon's coast. We also have a new position to fill on the team this year, as one of our instrumental team members, Bill Miller, our Marine Habitat Assistant Project Lead and ROV Electronics Guru, is retiring at the end of the month. We're going to miss him, but are excited for his next adventures, dirt biking to his heart's content. And if you know of a technically skilled person who may be interested, please send them our way. We have a lot of hiring that we've been doing and will continue to do. So, and of course, we can't talk about this next year without mentioning how you can get involved with us. If you're registered, you'll be getting those QR codes and links after the meeting, but also feel free to snap a picture now if you'd like. We have volunteer opportunities with the Marine Reserve Hook and Line surveys, which you heard about earlier today from Stephanie Fields, and we'll also be taking volunteers out with us to collect intertidal data this year at Otter Rock and Cascade Head to survey sea stars and mussel beds. We would love if you want to stay connected with us, and there are a few ways to do that as well. The easiest is subscribing to the Marine Reserve's quarterly e-newsletter, but you can also check out the upcoming events on the Marine Reserve's calendar on our website. That's a new feature of the website that we updated this year, so check it out if you haven't. And if you like being in the building with us today, save the date for April 11th and come back to the room right across the hall to interact with all Oregon Department of Fish and Wildlife programs. Both teams from the Nearshore Ecology Program will be representing our work there, and there'll be a fun passport activity to complete, which should be especially fun for the small scientists in your life. And as we wrap up today's presentations, I'd like to revisit the goals we shared at the start of the day. So hopefully now you know a little bit more about what this program is, the breadth of our work, and something new. And I'd love to put that knowledge to the test. So we have a few other sea star squeezies, stress squeezies, And if you can answer this question, same rules apply as last time. If you could raise your hand and wait for the mic. Can anyone from the audience tell us what are the two teams that make up the Nearshore Ecology Program? Non-ODFW staff, please.
Marine reserves and marine habitats.
Excellent. C-star for you. Yes. Okay. A nice slob. Great catch. Okay. And we have two more questions. So can anyone name two kinds of research or project that the Nearshore Ecology Program works on? This could be any kind of research or project that you heard about today.
Hook and line surveys and ROV surveys.
Wonderful. And last question, can you tell us one thing you learned today?
No one learned anything today. How sad. We failed the goals. Anyone share one thing you learned?
There are
Something
really
that
no wrong
surprised you.
answers.
All right, I see a hand.
The term donut economics.
Ooh, Sarah, you win. Wonderful. Thank you all so much for joining us. And again, we're going to mention that post-event survey. Please take it. You can choose to take that now or later at home. If you choose to take it now, you can feel free to scan that QR code and it'll bring you right there. You could win a Marine Reserves prize pack. So everybody make sure to put your name in there and contact information and we'll get that prize pack to you if you win. So thanks again. Please join us in the hall for hors d'oeuvres and and being able to communicate with us.